This is R.D. Sharma's solution, class 12, chapter 11, differentiation, exercise 11.3. Now these questions are based on the inverse trigonometric equations, and the solution of these questions, as we have seen in various resources available online, YouTube, Facebook, etc. The solution is only constrained to cos inverse and the content, but there is a boundary being given 1 by root 2 1, so x is between 1 by root 2 and 1. Now the solution of this differentiation, it doesn't only depend on the straightforward way, but also with reference to the boundary values being given. So let me tell you certain thing. If you have a square plus x square, normally we put x as a tan theta or a cot theta, because sec square theta is 1 plus tan square theta. Similarly, cosec square theta is 1 plus cot square theta. You'll see in every question I am going to tell and indicate what kind of things, what kind of substitution we have to give, so that we can solve that question easily. For example, if you have a squared minus x square, then in place of x, what we are going to put? Because we know that sine square equals 1 minus cos square. So we can put x as a sine theta or a cos theta, because cos square is 1 minus sine square is 1 minus cos square. If you have x square minus a square, then you can put x as a sec theta or a cosec theta. So there are certain solutions. For example, under root a plus x, a minus x, what we have to put? A cos 2 theta. Then we have a square minus x square by a square plus x square. So x square we will put as a square cos 2 theta. But this is just an idea being given, but in every question I am going to indicate what you have to put, what is the criteria we have to follow. But there are certain questions, the initial questions you have to understand, that we just don't do this by a straightforward way. We have to see the boundary also. This interval is as important as the solution of this question. Alright? Okay, let's start, because if you substitute, you will get the solution. But is the solution actually valid in this scenario, 1 by root 2 and 1? So cos inverse inside. So whatever you substitute, the resultant should be some cos, so that you can cancel this cos and cos inverse. So how do you get something in this 2x under root 1 minus x square, so that you get something cos? If I put x as cos theta, I told you when you have a squared minus x square, a is 1 here, 1 square minus x square you can assume. I just told you that in place of x, what are you going to put? You can put as a cos theta or a sin theta. A in this case, in our example, is 1 only. So either you will put cos theta or sin theta, it's up to you. Alright? Because sin square theta is 1 minus cos square theta is 1 minus sin square theta. So when we put these substitution, then you are supposed to get this cos theta out of it. And then you can cancel this cos and cos inverse, and whatever is inside you can differentiate. So I am writing, or you have to write for let y equals cos inverse of 2x under root 1 minus x square. X will be a sin theta or a cos theta. Let us put as cos theta. A is 1 here. Even if you put x equals to sin theta, then also you will get the answer. Right? You can try that. So x equals cos theta. So the inside, after cos inverse, whatever is coming, let me show you. 2 cos theta in place of x cos theta we are putting. 1 square, that is 1 minus cos square theta. Now 1 minus cos square theta is sin square theta. And under root of any square is that square gets cancelled. So you get sin theta only. And you have 2 cos theta outside. Now 2 sin theta cos theta or 2 cos theta sin theta is sin 2 theta. So if you solve this, putting x as cos theta or substituting x as cos theta, you will get inside sine 2 theta, and outside it is already cos inverse. But right now you cannot cancel this cos inverse with sine. You need to have a cos inside. Then only you will cancel it. But we know that sine theta is what? Cos pi by 2 minus theta. And cos theta is what? Sine pi by 2 minus theta. So you can always interchange sine and cos if you just change that theta, or 2 theta in this case, as pi by 2 minus 2 theta. Alright. So we have cos inverse, and sine 2 theta you have to write cos pi by 2 minus theta, because sine 2 theta is equal to cos pi by 2 minus theta. Now in your example, and I told you that in different sources, what you will do is, they have told cos and cos inverse you cancel, pi by 2 minus 2 theta you write, and in place of theta you have to replace whatever you have substituted, because x is cos theta, theta is cos inverse x. So in place of theta just write cos inverse x and then differentiate it. Differentiate is what? Pi by 2 is 0. If I differentiate it, pi by 2 is 0, minus 2 is 2, cos inverse x differentiation we already know, negative 1 by under root 1 minus x square. That is negative of 1 by under root 1 minus x square. Minus minus become plus. So twice of 1 by under root 1 minus x square. This is your solution. This is actually the solution of this question. But what is the meaning of x between 1 by root 2 and 1? Why the question is providing that? Because we are talking about the trigonometric functions, so we have to be aware and acknowledge and represent the answer or the understanding to the examiner. If x is between 1 by root 2 and 1, what does it mean? X is cos theta, what you have assumed. So this is 1 by root 2 and 1. And we know that what are the values of cos, so that you get 1 and 1 by root 2. We know that cos pi by 4, cos 45 degree is 1 by root 2. So you can just write cos inverse everywhere. Just to tell you that cos inverse 1 by root 2 is nothing but pi by 4, because cos pi by 4 is 1 by root 2. Actually sine cos and sine both 45 degree are 1 by root 2. So now in the middle one, cos and cos inverse you can cancel. Cos inverse 1 is what? Because cos 0 is 1. So you can write 0 here. Okay. So now theta is between pi by 4 and 0. When you have theta in between pi by 4 and 0, and the point from where do you start differentiating is pi by 2 minus 2 theta. So what you are differentiating is 2 theta. So multiply 2 theta both sides. So this 2 theta is actually between pi by 2 and 0. And between 0 and pi by 2, whether it is sine, cos, tan or whichever, cosec, sec or cot, it is always safe. Here you have pi by 2 minus 2 theta, so I am multiplying minus all side. So the inequality will change, because I have to show pi by 2 minus theta, pi by 2 minus 2 theta is between what? So I am now adding pi by 2. This is 0. This is pi by 2 minus theta is pi by 2 minus theta, which we are going to differentiate eventually. And we have differentiated already. And between this is pi by 2, because we have added pi by 2. Now this pi by 2 minus 2 theta is between 0 and pi by 2. It is between 0 and pi by 2. So 0 to pi by 2, you know that add sugar to coffee, from add sugar to coffee, or all students to college, that means that all are positive between 0 and pi by 2. So you don't have to worry about any negativity or positivity. That is, the result can be pi by pi minus 2 theta. The result can be pi by 2 minus 2 theta. It can be negative also. Since we have this value between 0 and pi by 2, we don't have to worry about the result. The result is 2 by under root 1 minus x square. Cos inverse under root 1 plus x divided by 2. Now with respect to trigonometry, we already know that what we have to replace here. But we have to be very sure that x is between negative 1 and 1. So when you replace something, when you substitute something, that theta, that content should be between minus 1 and 1, that between the limits. So first, whatever substitution you do, you need to get cos inside, so that you are able to cancel this cos inverse and cos. So we will be putting x as cos 2 theta. You'll just see what will happen. So the inside one will be under root 1 plus cos 2 theta divided by 2. 1 plus cos 2 theta is simply 2 cos square theta, as 1 minus cos 2 theta is 2 sin square theta. We already know that. So 1 plus cos 2 theta is 2 cos square theta divided by 2. 2 gets cancelled. Cos square theta is cos theta. Or outside you have cos inverse. Now you can just cancel it out. Theta will be there. Theta is, you can take the value of theta from here in terms of x and you can differentiate now. Alright? It's very simple. But directly you cannot do that. First, you have to tell whatever you have assumed, is it lying between negative 1 and 1 or not? So cos 2 theta, x is cos 2 theta. So cos 2 theta is between negative 1 and 1. Now apply cos inverse all along with all the three terms here in the inequality. So cos inverse minus 1 and cos 2 theta, cos inverse in the middle one gets cancelled, 2 theta. And cos inverse 1, you know that cos what value is your 1? Cos 0 is 1, cos pi by 2 is what? Cos 0 is 1, so you write 0. Cos inverse minus 1 is actually pi, because cos pi, cos 180 degree is negative 1. Now 2 theta, but we need theta here because we will be differentiating theta only. Divide by theta. So you have the value between pi by 2 and 0. Now we are quite safe. Why we are safe? Because we are dealing in the first quadrant. That is, add sugar to coffee, or all student to college. Here we have the value of theta between 0 and pi by 2, and between 0 and pi by 2 everything is positive. 0 pi by 2 pi, 3 pi by 2, like this it goes. Again 2 pi, then you go like that, just add pi by 2, pi by 2, pi by 2. But every quadrant, one of the trigonometric function is positive, others are negative. So cos inverse cos, you can just cancel these two. You are remained only with theta. But what you get here, because now we will be differentiating theta, but we cannot differentiate theta. Theta is what we have introduced. So you have to convert theta into x. Because x is cos 2 theta. So this is going to be cos inverse x equals 2 theta. If you take both sides as cos inverse x, or you can say cos, we can bring out on the left hand side. So cos inverse x is going to be 2 theta. So theta is going to be cos inverse x divided by 2. So differentiating theta means differentiating cos inverse x by 2. That's what your answer will be. So cos inverse x divided by 2. Now you have to differentiate d by dx. Cos inverse x we already know, it is negative of 1 by under root 1 minus x square. 2 is already there. This is your final answer. These are very easy steps. Solution is very easy. But this concept is also very important. Now differentiate sine inverse under root 1 minus x by 2. X should be between, or x has to be between 0 and 1. This need to be checked. If it is not between 0 and 1, you will not get the proper result. Or you need to change the result. 1 plus x, what did we put? Remember? X equals to cos 2 theta. When we have n1 minus x, again we have to put x as cos 2 theta only. Why? Because 1 minus cos 2 theta, we know that it is 2 sin square theta. So the inside one is 1 minus x, we will be replacing by cos 2 theta, or substituting. It will be under root 1 minus cos 2 theta divided by 2. 1 minus cos 2 theta is 2 sin square theta. It is 2 sin square theta only. 1 plus cos 2 theta was 2 cos square theta. Divided by 2, 2 gets cancelled, sin square theta will be sin theta. So eventually sin inverse is outside. So why is sin inverse of sin theta? So sin inverse you can cancel, you will get a theta. Theta will be equal to cos inverse x by 2, the same way we have done the previous question. And we will show the differentiation. It will be negative 1 by twice of under root 1 minus x square, as we have seen in the previous question. But the value of x should be between 0 and 1. So when you have taken x as cos 2 theta, you have to tell the examiner that I am between 0 and 1 and I am between so and so value when I take theta x as cos 2 theta. If x is between 0 and 1, which question is being saying, x you assume to be cos 2 theta. So when you take cos inverse, cos inverse all side, cos inverse cos 2 theta is cos inverse 1 here and cos inverse 0. As cos inverse 0 is what? We have already seen what is the value of cos something so that you get a 0. Cos inverse 1 means what is the value of cos so that you get a 1. So it is 0. Cos inverse 1 means 0. Cos inverse 0 means pi by 2. And it is 2 theta inside. It will be theta. Actually, you are going to differentiate theta only. But you have to check this also. Now divide both all of it by 2 because you need eventually theta. So theta is between 0 and pi by 4. And 0 and pi by 4 is in the first quadrant. So it's quite safe. Because again, add sugar to coffee, everything is positive at between 0 and pi by 2. If it is not lying between 0 and pi by 2, that means it is not between 0 and 1, x is not between 0 and 1, you have to change the value, you have to add or subtract certain value because inverse trigonometric functions, they are valid under certain boundaries, they are not defined everywhere. I hope you got the idea what I have been trying to tell you since last 2 questions and this question only. Now let us do this. Y is sin inverse sin theta. Theta only you have to differentiate. Theta is what? X is cos 2 theta you have taken. So cos inverse x is 2 theta. So theta is basically cos inverse by 2. So you have to differentiate this d by dx. It is cos inverse x by 2. 1 by 2 is already there. Cos inverse is simply negative 1 by under root 1 minus x square. So minus 1 by twice of under root 1 minus x square. Same thing here. Now I hope you got a fair idea what we are trying to do. Whatever is inside, we have to change it so that it should begin with sine. And what should we replace? Because it is a square minus x square types. So always and most probably we always take x as a sine theta or a cos theta. But in this case, as we have seen in the previous question also, we are replacing it by x equals a cos theta. A is 1 here because it is 1 square minus x square. So x we will be writing as x as cos theta. So what we are going to get, sine inverse of under root 1 square minus x square we have taken as cos square theta. So 1 minus cos square theta is sine square theta. And under root of sine square theta is sine theta only. Under root sine square theta is sine theta. So sine inverse and sine theta, sine in and sine inverse gets cancelled. So y is actually theta. So you have, if you do dy by d theta, it is dy by dx is basically differentiating theta only. But theta has to be in terms of x, not like that. But there is a boundary being given. X should be between 0 and 1. So when x is between 0 and 1, you have to show that yes, the theta also I have taken is between this boundary only. So x we have taken as cos theta. When you take cos inverse all of the sides, because there are 3 terms here in this inequality. So when you take cos inverse 0, cos inverse 1, cos inverse 0 is pi by 2, cos inverse 1 is 0. So theta is between 0 and pi by 2, and as I said, inverse trigonometric function always happens or valid, they are valid between certain boundary, not everywhere. Between 0 and pi by 2 it is safe. So y is theta. Theta has to be changed in terms of x because we cannot differentiate theta. That is what we have introduced. So theta is basically cos inverse x here. And now we have to find out dy by dx of cos inverse x. Cos inverse x is simply minus 1 by under root 1 minus x square. That is the direct what we have seen in the differentiation value. But the left side is equally important to show the examiner that this I know what I have been doing. I am not going out of the bounds. Differentiate tan inverse x divided by under root a square minus x square. Please remember x has to be between negative a and a. So whenever we talk about tan inverse, you need, in order to cancel, because you cannot directly differentiate it. If you want to, you can, because we know about that. But why not to cancel these 2 out? So we need a tan. So whenever we have a squared minus x squared kind of thing, we always take x is equal to, because we need something so that we get some formula of trigonometry. So x is equal to a sin theta will put. So what do we get? Tan inverse x is a sin theta, and then we have this under root a square minus, in place of x again, a square sin square theta. So we have tan inverse is already there, so we want this to be something with tan. A sin theta, a square multiplied by 1 minus sin square theta inside, if you take a square, and that a square will come out, so it will be a under root 1 minus s square. So a sin theta, you have a 1 minus sin square theta is cos square theta, and when we have a root, so cos square will cancel, so you get a cos theta. A gets cancelled, sin theta by cos theta is tan theta. So we wanted that, we got it. Tan and tan inverse you can cancel now. But since the boundary is also given, x has to be between negative and a. So you have by yourself thought that, oh, x equals to a sin theta I will use. So is that correct? Is that correct? So you have to emphasize and you have to show the examiner that this x equals to a sin theta will not point to any error. That means it is between the desired limit when we can have tan inverse and tan gets cancelled in that particular region. So sin theta will become x by a here. Divide both sides by a, what I am doing right now. Minus 1 here, x by a here. A and a gets cancelled. So x by a is between negative 1 and 1. So sin theta is, this x by a is between, that is x by a was what? Sin theta. So now you can take sin inverse. Or you can just say that, okay, we know that the angle minus 1, when we have minus 1 and 1, what will be the value of that angle? So sin inverse 1 and sin inverse negative 1. So this get cancelled. You have a theta, sin inverse negative 1. So it is negative pi by 2 minus 90 degree. Sin inverse 1, which is pi by 2, which is positive pi by 2, basically 90 degree. So we can just write pi by 2 here. Now theta between minus pi by 2 and pi by 2, that is, there is a point where we have pi by 2 and negative pi by 2. You can just take it in the denominator also, which is on the negative y-axis. So when we have between pi by 2 and minus pi by 2, you can cancel tan and tan inverse without even adding or subtracting anything from the theta. Otherwise, there can be some pi minus theta, there can be some pi plus theta, there can be pi by 2 minus theta, or whichever. Or a general solution kind 2 and pi plus or n pi, whatever we have already seen in the trigonometry. But here we are under the limits. So now you have to just differentiate theta. Theta is sin inverse x by a. Now let us differentiate this sin inverse x by a. And dy by dx of sin inverse x by a will be what? We know that it is 1 by under root 1 minus x square. Alright. So 1 by under root 1 minus x square. I'll show you also if you just want to see the solution or see how you need to write. So 1 minus x square by a square, and then x by a, there is x by a, so you have to differentiate x by a. And then x by a will give you 1 by a. But what is the denominator? A square minus x square by a square. This under root a square goes up. It will be a only. So a by under root a squared minus x squared. Alright. And we have a x by a also. And that gives you, because you have to use the product rule. The chain rule. The differentiation of x by a, 1 by a is constant. So you don't have to worry about it. D by dx of x is 1. So a gets cancelled. You have finally 1 by under root a square minus x square. This is your final solution. Now sin inverse x by under root a x square plus a square. So you need what? You have x by something, and that we have to convert into some sign. Something with sign, so that we can cancel sin and sin inverse. Now we already know what is the relationship between sin and cos. Sin square theta is plus cos square theta is equal to 1. But when you have under root a square plus x square, what do we put? X equals to a tan theta, that we have discussed earlier also. So x is a tan theta that we are going to put. So we will first resolve this. We will not jump into the differentiation directly. We will try to resolve this x a tan theta. Let us see this. A tan theta, x is a tan theta, divided by under root x square plus a square. X square is a square tan square theta, plus this is a square. You have a tan theta. A square, if you take constant, it will come out, means outside it will be a, because a square you can take outside and it will come a. So I am taking it as a, under root a square is a. 1 plus tan square theta is sec square theta. Because it is in root, so only sec theta will come out. Finally, you got a tan theta divided by a sec theta. A gets cancelled. Sin theta is sin by cos. Sec is 1 by cos. Cos gets cancelled. You just get sin theta. That's what we wanted. So sin inverse. Now finally what we are going to do, sin inverse sin theta. Sin you will just you can nullify, and theta is tan inverse x by, that we will differentiate. But is there any condition? No. There is no condition being given. So you can directly go ahead. X equals to a tan theta. So from here we will try to find out what is theta, because this x equals to a tan theta is being put by us, not by the examiner or whichever. We have put it. So we have to be very sure about that. So this is theta is tan inverse x by a. So essentially we have to differentiate this tan inverse x by a. Y equals tan inverse x by a. So dy by dx is 1 by 1 plus x square. 1 by 1 plus the content. So tan inverse inside this, it is x by a. So 1 by 1 plus x square by a square, you get a square. X square, a square goes up. So we have a square by a square plus x square. And since we have x by a also, we have to differentiate x by a also. So when you differentiate, 1 by a will come out. d by dx of x is 1. So you get 1 by a gets cancelled. You have a by a square plus x square. That is your final answer. A by a square plus s square. This is dy by dx. Now this, there is one more question coming like this. So for that, there is just one thing you need to know or recall. You might be knowing it, might not be recalling it. Remember, because some trigonometry we have learned long back, and to recall that it may be difficult. 2 cos square theta minus 1 is cos 2 theta. Cos 2 theta is also 1 minus 2 sin square theta. Please remember. So we will replace x by cos theta here, so that we can get 2 cos square theta minus 1. So 2 cos square theta, x is cos theta. So 2 cos square theta minus 1. And 2 cos square theta minus 1, I just told you it is cos 2 theta. So cos 2 theta it will be. Or cos 2x, whichever you call. So sin inverse cos 2x it is basically. And we have put a theta, so we have introduced a theta also. But theta is what we have introduced, not anybody else. So this is cos, and sin can always be converted. Sin pi by 2 minus theta is this. Sin inverse gets cancelled. You get pi by 2 minus 2 theta. So you have theta equals cos inverse x. So pi by 2 minus twice of theta is cos inverse x. This is your y. Y is pi by 2 minus 2 cos inverse x. But you have a boundary also. X is between 0 and 1. So pi by 2 minus 2 theta, whole of this you have to check between 0 and 1. Because that is what question is saying. Theta is being introduced by us. It is our responsibility to show that theta is also between this boundary. So cos theta is what? X. So this is cos theta between 0 and 1. And when you take cos inverse, that is cos inverse all the side or all the points, you get cos inverse 0. Cos inverse 0 is what? What is the value of cos? You get 0. So cos pi by 2 you get. And cos this 1, it is going to be cos 0 is 1, cos pi by 2. Cos 0 is 1, so cos pi by 2 is 0. So you can just replace this by 0 and pi by 2. And this cos and cos inverse of course gets cancelled. But we need pi by 2 minus 2 theta. This is just theta, okay? Cos inverse gets cancelled. So you just have a theta. Now you have to have pi by 2 minus theta, so you need to have a 2 theta first. So you have 2 theta, multiply everything by 2, so pi, 2 theta and 0. Now you are negative, so multiply all the elements by negative. The angle changes, means the inequality changes, multiplied by minus. And then we have to add pi by 2, so that we get pi by 2 minus 2 theta. Add pi by 2 minus pi is what? Negative pi by 2. It's pi minus pi by 2 is pi by 2, because it is pi by 2 minus pi, it is negative pi by 2. So let us write negative pi by 2 here. Inside this, we already have pi by 2 minus 2 theta. And here 0 plus pi by 2, so it is pi by 2 only. Now, we have already seen in one of the question that when you change sine and means try to cancel this sine and sine inverse, there are possibilities with their inverse trigonometric background knowledge we have, that we cannot do it directly. So minus pi by 2 and pi by 2, you can do it in between negative pi by 2 and pi by 2. So we have got negative pi by 2 and pi by 2. This is the interval. Okay, this is already the interval. So we don't have to worry. We just have to differentiate it, dy by dx. So pi by 2 minus 2 cos inverse x, we are going to differentiate. Pi by 2 is a constant, so it will be 0. Minus 2 cos inverse x is 1 by under root 1 minus x square, negative. So negative positive, twice by under root 1 minus x square. This is dy by dx. Now we have to differentiate sine inverse 1 minus 2x square. I just indicated you, if you put x as sine theta, 1 minus 2 sine square theta is equal to cos 2 theta. Other things remain the same. The previous question and this question are exactly almost similar. Just have to put x as sine theta, so that you get 1 minus 2x square as 1 minus 2 sine square theta, that is equivalent to, or that is equal to cos 2 theta. I hope you got the idea. This is cos 2 theta. You'll do it by yourself. Differentiate cos inverse x by under root x square plus a square. So x square plus a square, wherever it is, we have seen so many questions. We have already placed x as a tan theta and a cot theta, like that. Here we are going to, because we need cos inverse, so something so that we can cancel it out with cos inverse. So x equals to a cot theta, we are putting x is a cot theta. Here x square plus a square, so x square will be a square cot square theta. A square will remain like that, so it will be a cot theta. And you have a square, you can take common. It's just a. It comes out under root 1 plus cot square theta, which is nothing but cosec square theta, and since it is under root, so it will be cosec theta. Under root of cosec square theta will be cosec theta. Alright? So we have a cosec theta. Cot is cos by sine. Cosec is 1 by sine. So this sine gets cancelled, and cos it will be. So why we have done all this? Just because we know that it gets cancelled. And since there is no boundary being given, cos inverse, cos and theta, so you can just cancel this cos inverse. So you have to differentiate only the theta. So when we have placed x equals a cot theta is going to be x by a, and theta is going to be cot inverse x by a. So now put this theta as cot inverse x by a, just put it here, cot inverse x by a, dy by dx of cot inverse x by a is negative by 1 by under root 1 plus this thing, x by a whole square. So differentiation of x by a also, it is going to be 1 by a. So what do you get? A square plus x square, and a square will be in the denominator. I am taking it into the numerator. Negative a square, a gets cancelled. You have 1 by negative 1 by negative a by under root a square, a square plus x square only. Okay, this question and the next question, they are almost similar. So please, pay more attention here. There is a boundary being given, that is the where x should belong, negative 3 pi by 4 and pi by 4. Alright. So this sin x plus cos x by root 2, what do we do? 1 by root 2 is sin and cos. The basic point here is this 1 by root 2 sin and cos 45 degree will be, see, this is 1 by root 2, 1 by root 2 if you take with sin x and cos x, because it is in the denominator, you can take separately. This is 1 by root 2 sin x, and then we have cos x 1 by root 2. Cos x 1 by root 2. Okay. Why we have written this? Because sin pi by 4 and cos pi by 4 both are 1 by root 2. Sin 45 degree or cos 45 degree, they both are 1 by root 2. And since the question is already giving us 1 by root 2, so we can replace it that, so that we can get a formula out of it. And that formula should contain sin, so that we can cancel it with sin inverse. The whole idea is that sin x cos pi by 4 plus cos x 1 by root 2 is sin pi by 4, and sin a cos b plus cos a sin b. What it will be? Sin a plus b. So sin x plus pi by 4. So this is a, this is b, and all these formula are very important, They can be applied anywhere. You never know. So need to mug up all these. Sin inverse sin x plus pi by 4. And x plus pi by 4 again, since there is a limit being given, minus 3 by 4 and pi by 4. So you have to show the examiner that when I am cancelling sin and sin inverse in this case, I am taking care of the limits. So negative 3 pi by 4 and pi by 4, x is between these two. So x plus pi by 4, so just add pi by 4, both here also pi by 4, here also pi by 4. So pi by 4 minus this pi by 4 plus pi by 4 is what? Pi by 2. So this is pi by 2. This is x plus pi by 4, and pi by 4 minus 3 by pi by 4 is minus 2 pi by 4, and that brings down to minus pi by 2. Now between minus pi by 2 and pi by 2, you can always cancel sin and sin inverse. That we already seen in the previous questions. So direct differentiation you have to do now. Sin and sin inverse cancel. You just have to differentiate x plus pi by 4. And this is x will be equal to, this pi by 4 is 0, x is going to be 1. Differentiation of x is 1. Same thing here. Exactly same thing. So you have to write cos inverse, and this is sin cos x and sin x, and whichever formula you know, but that formula should be cos something, because ultimately you have to cancel this cos inverse and cos. So whatever you do, first thing is this, that's 1 by root 2, you have to write something. So what you have to write here? You have to write cos pi by 4. Because remember, cos pi by 4, sin pi by 4, both are 1 by root 2. So we have cos x, cos pi by 4. And then we have sin x and sin pi by 4. So cos x, cos pi by 4, sin x, sin pi by 4. Alright. And this formula, that is cos a, cos b plus sin a, sin b, is cos a minus b. And it's up to you. How do you pick up whether you want cos x first or cos pi by 4? It's up to you. But the final version, final output of this, what we have done is cos a minus b. A I have taken as pi by 4. So cos pi by 4 minus 1. You already have a cos inverse outside. Cos inverse you can cancel. You have pi by 4 minus x. You have to differentiate. Pi by 4 will be 0. And negative x is 1 only. So negative 1 will come. The differentiation is not that issue. It will be negative 1, and that is your answer also. But you have to show examiner that have you done it correctly? X is between negative pi by 4 and pi by 4. So this negative pi by 4, x is between these two. And you have to have pi by 4 minus x. Pi by 4 minus x, then only you can cancel cos and cos inverse if it is between 0 and pi. So let us see. Multiply negative all the way, and whenever you multiply negative, the inequality sign changes. It's going to be negative x. Here you have negative pi by 4. Here you have pi by 4 plus pi by 4. Now you add just pi by 4 everywhere. Just add pi by 4. Here also you add pi by 4. So you have pi by 4 minus x, and this is 0. This is pi by 2. Now, there is no problem because sine and cos inverse you can always cancel if it is between 0 and pi. But you are already between 0 and pi by 2, so it doesn't matter. Alright, you got the point. 0 to pi you always cancel cos and cos inverse, but you are between 0 and pi by 2. So you are good to go, and I already told you what is the differentiation. It is negative 1. Alright. So final answer is negative 1. But this boundary has to be taken care. Please remember, I always say that. Now differentiation. Now this is the interval, and most of the people are asking why this is being considered, and why are we just not differentiating tan inverse, making something tan inside and just solve it. So I would like to add to it, and people were asking also, so I'll just tell you that there is a range, there is a boundary. If you have a sine inverse and you have a sine inside, the theta will only come out, that is x inverse into x, normally we consider is 1 by x into x, so we cancel it, we say it is 1. So in the same way, analogy if you make, if theta is coming out, by an analogy that sine inverse sine can be cancelled out. But it will not come as theta just by choice. The theta will only come out with certain thought about the trigonometric functions. If theta is between minus pi by 2 and pi by 2, these both are included, then only theta will come out. For example, if it would have been sine inverse, then you need to check whether whatever you have thought, y equals to sine theta, y equals to cos theta, whichever you think you have thought, that has to be within these limits. For example, cos inverse and cos theta, same thing. When you cancel these, you get a theta. How do you get a theta? You don't get theta always. That theta should be between 0 and pi. Then only you can have cos inverse cancelled out. And this question is tan inverse. So if you have tan inverse or tan inverse tan, that theta will come out only when the theta is between negative pi by 2 and pi by 2. So in sine it was inclusive, here it is not inclusive. So if you know the graph of sine cos tan, then you will be able to tell, oh yes, this is correct. Similarly, we have for sec, cosec, cot, when we can cancel it, when we can assume it to be a kind of inverse thing. So this question is important, but the range and the boundary also check is vital to solving this question. Okay, when I told this and I took some more time in solving the question, people have disliked like anything. Anyways, let's come down to this question, and there are multiple questions like this. So this is two things. One more time I am telling you that differentiation is one thing, but differentiation of a trigonometric function always should be inside the limits or boundaries, because you cannot have differentiability everywhere. So for those who want to understand, I'm going to tell them, and those who just want to see the reference, there is a reference answer here. Okay, whenever we solve this kind of questions, we always see whatever is inside the root. So you have root 1 square minus x square. 1 square is a here. So when you have under root a square minus x square, you always put x as a sine theta. Sometimes you also put it as x equals to a cos theta, because sin square theta plus cos square theta is 1. Since a is 1 here, x is sine theta we are putting. So this is sine theta. The inside one I am telling you. X is sine theta. 1 plus under root 1 square minus x square, that is 1 minus sine square theta. So you have a sine theta here. 1 plus 1 minus sine square theta is cos square theta. And when you have a under root of cos square theta, it will be cos theta only. Now sine theta can be written as twice of sine theta by 2 cos theta by 2, because sine 2 theta is 2 sine theta cos theta. When you have a theta, it will be theta by 2. So you have 2 sine theta by 2 and cos theta by 2. This is cos theta by 2, okay? And 1 plus cos theta will be what? It will be 2 cos square theta by 2. These equalities and results should be in your tips. 2 cancel, cos 1 cancel, sine by cos, so it will be tan theta by 2. Finally you got tan theta by 2. So this is tan inverse, and then we have this tan theta by 2, tan inverse tan theta by 2. So tan inverse you can cancel these out, but finally tan inverse will cancel out and theta by 2 will come. Theta is basically sine inverse x. So you have to differentiate sine inverse x by 2. So y is sine inverse x by 2, you have to differentiate it. Sine inverse x is simply 1 by under root 1 minus x square. You have a twice here. So this is your final differentiation. I am not denying that. And you will get a proper answer here. So what is the value of this negative 1 and 1? Why we have this? Because this x is the sine theta you have introduced. So you have to show the examiner that I have a check. And then the result may vary if you don't check. Sometimes it may come as when you take this out, it will be pi minus theta, pi by 2 plus theta, or negative theta, So now this sine theta is between negative 1 and 1, because you have taken y as this x is sine theta and x is sine theta, so you put sine theta here, between 1 and minus 1. Now what is the value of theta for which the sine is negative 1? What is the value of sine for which the value is 1? So this sine inverse minus 1 and sine inverse 1, you will get pi by 2 and minus pi by 2. You know that? Sine pi by 2 is 1 only. So sine inverse, you can write in place, so sine inverse 1 pi by 2, sine inverse minus 1 minus pi by 2. So when we have theta by 2, because you need to differentiate theta by 2, make it as theta by 2. So it is between negative pi by 4 and pi by 4. And I just told you that tan inverse is only possible when there is a periphery inside which it belongs. Then only this whatever is inside, here we have theta by 2 inside, that will come out without any addition or subtraction to it. So if it is between negative pi by 2 and pi by 2, these two not inclusive, then this minus pi by 4 and pi by 4 is inclusive in this interval. So there is a big range, and this small range minus pi by 4 and pi by 4 is a part of it. You can differentiate it. So this is how differentiation will be done, and that is your answer. I hope you got the idea. Okay. So here we have tan inverse x by a plus under root a square minus x square, and x should lie between negative a and a. Alright. So we have, don't worry about anything, just see the root. Root is a square minus x square. So x is a sine theta. That is what you have to put. I am just saying that refrain from putting x as a cos theta, because there may be addition to the complexity. So always write x equals to a sine theta. A is valid here. So a square minus a square sine square theta. Inside one I am telling you a sine theta by. So a sine theta a plus. This is going to be a square 1 minus sine square. So it is going to be a square cos square under root of this. So a cos theta will come out. So a you can take common here. So you have a sine theta, and you a take common 1 plus cos theta. So a is exactly same thing which we just encountered in the previous question. Sine theta is 2 sine theta by 2 cos theta by 2, and 1 plus cos theta is 2 cos square theta by 2. 2 gets cancelled. this cos cancels, sin theta by 2, cos theta by 2 is tan theta by 2. So this tan theta by 2, this is just the simplification. We haven't started the differentiation as of now. So tan inverse tan theta by 2. So you can just cancel this tan inverse. Theta by 2 will be there. Theta by 2 differentiation. Theta you just replace it by sin inverse x by a. But the range is negative a to a x should be between this. What is x from here? It is a sin theta. This is a sin theta. So in order to put this x, divide everything by a. You need x by a. X by a is sin theta in your case. You have chosen that already. So this is negative 1 and 1. And same discussion what we had just now in the previous question. This x by a on the left you get minus pi by 2. And right one will be pi by 2. So what is the value of sine 1? What is the value of sine negative 1? No, sine inverse 1 is pi by 2. Sine inverse minus 1 is minus pi by 2. So this is theta by 2. So now divide also by 2. So you get minus pi by 4 and pi by 4. With the same discussion, this minus pi by 4 and pi by 4 is lying between the range which we need to cancel this tan and tan inverse. That is minus pi by 2 and pi by 2. So this is in between that. Inside this. So this range is valid. So you just don't worry about anything addition or subtraction to theta by 2. Just bring theta by 2 outside. Cancel tan inverse. And theta by 2 is, we have to differentiate theta by 2. So y equals to theta by 2. But you cannot differentiate theta. Theta is being introduced by you. You have to convert it into x. So theta will be sin inverse x by a from what we have chosen. So sin inverse x by a, and there is a 1 by 2 also. When you differentiate this d by dx, half will come outside. Sin inverse x by a will be 1 by under root 1 minus x square. That is 1 minus x square by a square. So this denominator will be a square minus x square by a square in the under root. And differentiation of x by a is of course 1 by a. So this is a square minus x square by a square minus x square under root goes up, under root a square goes up, under root a square goes up, a will come out, under root a square minus x square in the denominator, 1 by a is there, 1 by 2, a gets cancelled, 1 by twice of under root a square minus x square is your final differentiation, 1 by twice of under root a squared minus x square. Alright. Differentiate sine inverse. This question and the next question, they are exactly same, almost similar. Alright. So what you will understand here, how to solve this, it will be valid and have similarity with the next question. So you have to just go through the under root 1 minus x square, so it is 1 square minus x square, equated with a square minus x square, under root a square minus x square. So just put x as a sin theta. So x is a sin theta, a is 1, that is why I am not writing it, a is 1 here. So x is sin theta you have to put. So theta will be equal to sin inverse x, because ultimately you have to differentiate this only whenever the theta comes out when you cancel sin and sin inverse. Now let us go inside and solve this first. Inside what I am doing, x is sin theta we have chosen, plus under root 1 minus x square is sin square theta, 1 minus sin square theta, and divided by root 2. This is under root 2. Okay, sin theta and under root 1 minus sin square theta, 1 minus sin square theta is cos square theta, so cos square theta under root is cos theta only. And you have root 2 in the denominator, so sin theta, this is root 2, so this is 1 by root 2 plus cos theta, this also 1 by root 2. Now you can take this first one as cos pi by 4, second one is sin pi by 4, because sin pi by 4, cos pi by 4, sin 45 degree, cos 45 degree. They are 1 by root 2, they are the same number. So I am writing sin theta, in place of 1 by root 2 I am writing cos pi by 4 plus cos theta, and this is 1 by root 2, so I write it as sin pi by 4. So sin a cos b plus cos a sin b, that is simply sin a plus b. So sin theta plus pi by 4. And you have a sin inverse outside also. So sin inverse we have taken from here, and if you want to cancel these out, you have to be very sure that it should lie between negative 1 and 1. And we know what is the boundary and limit of trigonometric functions also, or identities also. So x is what? Sin theta. So sin theta is between -1 and 1. That means it is between minus pi by 2 and pi by 2. You can assume it to be, just add sin inverse. You will get the proper solution, sin inverse x. So this is minus pi by 2 and pi by 2. And now you need theta plus pi by 4 to be checked. So in order to check this theta plus pi by 4, just add pi by 4 on both the sides. All the sides basically. Theta plus pi by 4 has to be added to every element. Theta plus pi by 4 also will be there. So pi by 2 plus pi by 4 will be, see, whenever there is an issue, you are not able to get the LCM, multiply 4 and pi, 4 pi, 2 and pi, 2 pi, and multiply the denominator now. 2 into 4, 4 2 is 8. 6 pi by 8, that is 3 pi by 4 it is. So 3 pi by 4. Now right here 3 pi by 4. And this is between pi by 4 minus pi by 2 is of course pi by 2, pi by 4 only. Pi by 2 is a bigger number. So minus pi by 4. Now minus pi by 4 and 3 pi by 4. That is, it is between minus pi by 2 and pi by 2 that we already needed. Minus pi by 2 and pi by 2. So we have to deal with theta plus pi by 4 without worrying anything. So this is the limit. We are inside that, so we don't have to worry or be concerned about that. So now this theta or theta plus pi by 4 is between negative pi by 4 and 3 pi by 4, which is acceptable. So just have to differentiate theta plus pi by 4. Why is theta plus pi by 4? Because theta is introduced by you, so you have to convert it into x. So I told you theta is sin inverse x. It is sin inverse x plus pi by 4. You just have to differentiate this, dy by dx. So this is pi by 4 will be 0, sin inverse x will be 1 by under root 1 minus x square. That is your final answer. Now as I told you, this is also similar to the previous question. The boundary is also the same. So same result is going to come. Same process should be followed. And what we'll do here is x equals to sin theta we'll put. Because everything depends on what is inside the under root 1 minus x square. So assume it to be under root 1 square minus x square. So it is equivalent to under root a square minus x square. Whenever you have this x, normally we put as sin theta. X equals to a sin theta. A is 1 in this case. But people are solving using x equals to cos theta also. That will just add some, a bit of complexity. But you don't have to worry about it. Just always put, whenever you get this, x as sin theta. That has to be de facto. This use as de facto. Okay. So now the inside one I'm telling you, when we put x as sin theta, so sin theta plus under root 1 minus sin square theta divided by under root 2 you have. So you have sin theta plus 1 minus sin square theta is cos square theta. Because sin square theta plus cos square theta is 1. 1 minus sin square theta is cos square theta. Under root cos square theta is cos theta only. This is cos theta. So you have sin theta plus cos theta and divided by root 2. So root 2 you can take separately. And what do you get? You get sin theta 1 by root 2 in place of 1 by root 2. You can have sin pi by 4 or cos pi by 4. But we have to make a formula out of it. Because sin 45 degree, cos 45 degree, sin pi by 4, cos pi by 4, all are 1 by root 2 only. So in place of 1 by root 2, you can put any value which you need. But we need to make a formula. Remember, sin theta 1 by root 2 is sin pi by 4 we are writing. And then we have cos theta. And this 1 by root 2 I am taking it as here cos pi by 4. So sin A cos B plus cos A sin B, or cos A cos B plus sin A sin B. They both comes down to cos A minus B. So our final will be cos A minus B, that is theta minus pi by 4. So this is just a simplification I am doing. Haven't even started the differentiation. So cos A minus B is the formula here. And now we'll bring that cos inverse, because this is the inside stuff I was telling you. So cos A minus B, and this is theta minus pi by 4. So this is the simplification. Now this is the part which we have done. So you have to add this cos inverse because it is outside. So cos inverse cos theta minus pi by 4. So this cos inverse you can just cancel, but that is only possible when you have a limit, that is it has to be between 0 and pi. So what to do? You will see in this question, if you don't consider negative 1 to 1, what will be the problem that is going to arise? Because you will not get the proper solution here. Because see, minus 1 and 1, this is where the x should be inside. Minus 1, 1 not included, please remember. Now you need some x is actually sin theta you have put. So in place of x, just replace it by sin theta. So x is sin theta between negative 1 and 1, and we already know what is that. It is between pi by 2 and negative pi by 2. So negative pi by 2, it is pi by 2, and this is sin theta between negative pi by 2 and pi by 2. Okay. Now this is a theta basically, not sin theta, it is theta. Because assume it to be that we have applied sine inverse all the sides, all the content here. So negative pi by 2 and pi by 2. But you need theta minus pi by 4, that is inside. You are checking that only, no? So theta minus pi by 4, so you have to subtract theta by this pi by 4 on all the sides. So minus pi by 2 minus pi by 4, theta minus pi by 4, and pi by 2 minus pi by 4. So this is minus 3 pi by 4. And this is theta minus pi by 4, this is pi by 2 minus pi by 4 is going to be pi by 4 only. Now this is the limit which is inside 0 and pi. Or no, this is not between 0 and pi, because you have gone ahead of that or outside that. Alright. So here there is, whenever you take this out and there is a limit which you are surpassing. So cos and cos inverse, when you cancel, this will be negative of the theta, whatever is going to come inside. So it will be negative of theta minus pi by 4. I hope you got the idea. Simply, if you do it directly, you will get theta minus pi by 4 and you will start differentiating it. No, it will be negative of theta minus pi by 4. So minus 3 minus theta plus pi by 4. Theta is of course your sin inverse x plus pi by 4. So why is this? So dy by dx is minus sin inverse x is 1 by under root 1 minus x square. Differentiation of pi by 4 is going to be 0. So this is how negative of 1 by under root 1 minus x square will come after taking care of all the limits and all the boundaries which is provided in this question. Differentiate tan inverse 4x by 1 minus 4x square. And this is the boundary, or you can say the limit or periphery we have to follow. Now, the first thing is we need inside tan inverse some result so that we get a tan, so that we can cancel it out. I am writing the inside one, which is 4x. I am writing it as 2 into 2x. 1 minus 4x square. 4x square is 2x square. If you take 2x as tan theta, the x will be tan, basically tan theta you need, so it will be theta will be tan inverse 2x. That we are going to use, but later on. Right now we are at tan theta equals 2x. Let us put it here. So 2 into 2x, we have tan theta divided by 1 minus 2x is tan theta, so tan square theta it will be. Now we already know by trigonometry 2 tan theta by 1 minus tan square theta is tan 2 theta. So we have got a tan here that we actually wanted. So it will be tan inverse tan 2 theta. Okay. 2 theta you can take it out because tan inverse you can cancel. But this is only possible for certain interval, which is minus pi by 2 to pi by 2. So let us go to the limitation which is being given, negative half to half, which is inside x. So we have minus 1 here, and this is 2x, and this is your 1. Okay, we have multiplied 2 everywhere. 2x is tan theta we have taken, so tan theta will be less than 1 and less than minus 1. So if you want to find out the theta for this, it will be pi by 4 and negative pi by 4, because we know tan pi by 4, tan 45 degree is always 1. It is 1. And tan minus pi by 4, because sin minus theta is minus sin theta, tan minus theta is minus tan theta. So we can write always minus pi by 4. Okay. Now this is your theta, and we need 2 theta because when you cancel tan and tan inverse, you will get 2 theta. So you need to have 2 theta. So when you multiply 2 everywhere, what do you get? You get minus pi by 2, 2 theta, and this is between negative pi by 2 and pi by 2. This 2 theta is between this. So if we cancel this tan inverse, the range is negative pi by 2 to pi by 2, but it is actually equal to the cancellation. When you tan inverse cancel, you will get minus pi by 2 and pi by 2. So this is the range, and this range we already have, and it is not inside, but it is actually equal to it. Now you can finally take the 2 theta. This is 2 theta. So what is theta here? Tan inverse 2x. First of all, it is tan inverse 2x, and since we have twice of theta, so it will be twice of tan inverse 2x. So basically you have to differentiate y equals twice of tan inverse 2x. Alright. So dy by dx, let us do 2. Tan inverse 2x is what? Tan inverse of something will be 1 by 1 plus this content square, 2x square in this case. And differentiation of 2x by the chain rule, it will be 2. So 2 to the 4, 1 plus 2x whole square is 4x square. This is your final answer. Differentiate tan inverse 2 raise x plus 1 by 1 minus 4 raise x. And it is between, the x has to be between negative infinity to 0. And there are certain questions which are coming, which are like this only. And there is just one, when you take this boundary, there is just a simple trick which we'll use. So what we have to do, we have to turn this into something tan, so that we can cancel tan inverse and tan. So 2 raise x plus 1 divided by 1 minus 4 to the power x. This 2 raise x plus 1, we can write it as 2 raise x into 2 raise 1. 1 minus 4 raise x 2 to the power x whole square, you can write always. Now let us take 2 to the power x as tan theta. When you take 2 to the power x as tan theta, what do you get? You get tan theta, 2 raise x is tan theta, and you have 2 also. So 2 tan theta and divided by 1 minus 2 raise x is tan theta whole square. Alright. Now we have just seen a question like this. 2 tan theta by 1 minus tan square theta is tan inverse tan 2 theta. This is tan 2 theta, which we have just found. So let us write it here, tan 2 theta. So if you want to cancel, 2 theta has to be differentiated. Theta is simply when you find out tan inverse 2x, 2 raise x. But it is in the range or not, that we have to check. So negative infinity to 0, x is between this. Now let us take all the values to the power of 2. So 2 to the power minus infinity, 2 to the power x, and 2 to the power 0. 2 to the power of 0 is 1, 2x will be like that. And 2 to the power minus infinity, because it's something to the infinity, this 2x, 2 raise x is actually tan theta, because we have assumed tan theta to be 2 to the power x. So this is 2 to the power minus infinity is 1 by 2 to the power infinity. Anything to the infinity is infinity, and 1 divided by infinity is what? 0. 1 by infinity is 0. So this ultimately becomes 0. 2 to the power minus infinity, you can replace it by 0. So write it 0. Okay. So 0 and 1, no problem. And if you want to take the tan of, what is the value of tan, so that you get 1, what is the value of tan, so that you get 0. So it is simply, this is pi by 4, and 0 is of course 0. Tan 0 is 0. So your theta becomes the boundaried by 0 and pi by 4. Now you need 2 theta multiplied 2 everywhere. So 0, this is 2 theta, 2 pi by 4 is pi by 2. Now what is the range? When you cancel tan and tan inverse, it has to be between negative pi by 2 and pi by 2, and you are well inside that here, 0 to pi by 2. Now let us take the differentiation, y equals to 2 theta. So 2 into theta, what is theta here? Tan theta equals 2 to the power x, that you have assumed. So theta will be equal to tan inverse 2x. It is going to be tan inverse 2x. So this is 2, theta will be tan inverse 2 raise x, it is tan inverse, not square. I'll just change it. Ty by tx, so twice. Now tan inverse is simply 1 by 1 plus square of that thing which is inside tan. So 1 plus 2 to the power x to the power 2. So it will be 2 to the power 2x, which is essentially 4 to the power x actually. And what after that? Because we have to follow the chain rule. So 2 to the power x, differentiation of 2 to the power x will also be done. 2 to the power x. See, tan inverse x, differentiation is 1 by 1 plus x square. X square. So 2 to the power x to the square. So 2 to the power 2x, which is actually 4x. What is 2 to the power x? It is of the form a to the power x. And a to the power x differentiation is what? A to the power x log base EA, which is 2 here in this case. So what all we got? 2 to the power x and 2 you can combine. It will be 2 to the power x plus 1. And log base E2 will be there. 1 plus 4 to the power x. So this, the next question which is upcoming, most of the things will remain same. Alright. So this is the final answer of this question. Now differentiate tan inverse 2a raise x, 1 minus a raise 2x, a should be greater than 1, x should be between infinity and 0. So the solution I always show just for those people who just want to do it by themselves, and I actually solve because those who want to understand how this solution has come, what are the steps. So that is what we have to get a tan inside, because tan inverse is there. We need to get a tan so that we can cancel this tan and tan inverse. Okay, so 2a to the power x by 1 minus a to the power 2x. A to the power 2x. So I am writing it as a to the power x whole square. It's same thing. So a to the power 2x, I am writing it as a to the power x 2 raised to the power 2. So we know that a to the power x, if you put tan theta, you will get the desired result. So a to the power x tan theta we have written. And in order to find the theta, you will get tan inverse a to the power x. And that will come just now, because we have to differentiate that only. So you replace a raised x by tan theta. So 2 tan theta divided by 1 minus tan theta whole square, or tan square theta. And we have just seen in the previous 2 questions, it is tan 2 theta. So tan inverse, tan 2 theta, tan inverse cancel, 2 theta will be there. Y equals to 2 theta, you have to differentiate this 2 theta. Theta is already tan inverse a to the power x, so twice of tan inverse ax. You have to differentiate that. But you have to check that also. Negative infinity to 0, this x is lying between negative infinity and 0. So we have to differentiate that also. What is x? What is x here? Now let us take all to the power of a. All these elements which you see in the inequality, I am raising them to the power of a. So a raised minus infinity, a raised x, a raised 0. So a raised 0 is 1, 1, a raised x is x, a to the power minus infinity. As we have just seen in the previous question, which was 2 to the power minus infinity, it was 0. So you get a 0 here. A to the power minus infinity is 1 by a to the power infinity. Anything to the power infinity is infinity always. So 1 by infinity is going to be 0. And what is the tan angle of, what is the tan inverse of 1 and 0? It is pi by 4. And this is going to be theta, and this is going to be 0. So you have to be between minus pi by 2 and pi by 2 in order to cancel tan inverse. And since it is 2 theta, you have to multiply 2 theta also. So you get pi by 2 and 0. So you are well inside negative pi by 2 and pi by 2. Minus pi by 2 and pi by 2. Okay. So dy by dx, just do it. Dy by dx. It is twice tan inverse a raised x 1 by 1 plus a raised x whole square. This is the differentiation. A raised x differentiation is a raised x log a, which is a case, in this case previous question it was 2. So this is the same question as the previous one basically. So 2 into a to the power x log base e is a by 1 plus a to the power 2x. Alright? Is this clear? Differentiate sine inverse under root 1 plus x plus under root 1 minus x by 2. So we need sine inside. We need a sine inside this. Please remember 1 plus cos 2 theta is always 2 cos square theta. 1 minus cos 2 theta is always 2 sine square theta. This we are going to use in this also and next few questions also. So 1 plus in place of x, replace it by cos 2 theta. 1 plus cos 2 theta. So, and 1 minus x, 1 minus cos 2 theta. So what you will get here is theta will be, see, cos inverse x is 2 theta. Theta will be cos inverse x by 2. So essentially you have to differentiate in the later part of this question cos inverse by 2. Now 1 plus cos 2 theta, 1 minus cos 2 theta inside the under root, and let us solve this first. 1 plus cos 2 theta, I just told you it is 2 cos square theta. 1 minus cos 2 theta is, I just told you it's 2 sin square theta. Under root 2 you can take common. Cos square theta will be cos theta. Under root cos square theta is cos theta. And under root sin square theta is sin theta. Just write sin theta. There is a 2 in the denominator also. So under root 2 you have taken, which is outside, 2 is already there. But we need a under root in the denominator also. So multiply numerator denominator by root 2 just to include this root 2 inside. So this above will become root 2 will be 2 gets cancelled. So there will be under root 2 in the denominator. I am separating them with the 2 content. So we know that we are going to use certain formula, the trigonometric formula. So cos theta will be like that. Write just 1 by root 2. You can just write it as sin pi by 4. And sin pi by 4 is what? It's 1 by root 2. Here we have sin theta. Just write sin theta. 1 by root 2 you can take it as cos pi by 4. Cos pi by 4 is what? Cos pi by 4 is again 1 by root 2. Alright. So now this is a formula of sin A plus B. So you can just write it as sin theta plus pi by 4. And since this is the inside one, the outside one is sin inverse. So use sin inverse. Sin inverse sin theta plus pi by 4. So theta plus pi by 4, sin inverse gets cancelled. Theta plus pi by 4, cos inverse by 2 plus pi by 4 it will be, because theta plus 4, theta I already told you what is there. You have to differentiate this. Y equals cos inverse x by 2 plus pi by 4. But let us see theta plus pi by 4, which we are cancelling sin and sin inverse, whether this theta plus pi by 4 corresponds to this periphery. Yes. Cos 2 theta, because x is cos theta you have taken. It is between 0 and 1. Now take the cos inverse everywhere. Cos inverse 1 and cos inverse 0. You know that cos 0 is 1. You know that cos pi by 2 is 0. So you have 2 theta between 0 and pi by 2. What is theta? Divide by 2 everywhere. You get 0. Here you get theta. Here you get pi by 4. Pi by 4. Now you need pi by 4 also, because you have to add pi by 4, because we are checking for theta plus pi by 4. The range is minus pi by 2 and pi by 2 if you want to cancel sin and sin inverse. So this theta you have to add pi by 4, and when you add pi by 4 it will be 0 and pi by 2. I have not added, I am just saying this will be between 0 and pi by 2. Now let us differentiate this cos inverse by 2, which is minus 1 by under root 1 minus x square by 2. Pi by 4 will be 0. Differentiate tan inverse under root 1 plus a square x square minus 1 by x. So whenever this type of question with under root comes, you have to eliminate the under root. For that, this you just see it is of the form a square plus x square. Okay, so whenever we have this form, we always put the content as tan theta. So what do we have? I am doing the inside one. Under root 1 plus a square x square minus 1 divided by ax. So put ax as tan theta. Okay, ax as tan theta. So what you'll get inside, 1 plus tan square theta minus 1 divided by ax will be tan theta. 1 plus tan square theta is what? Sec square theta. Sec square theta is 1 plus tan square theta. So it will be under root. This is actually under root sec square theta. So under root sec square theta will be sec theta only. So sec theta will come out. Sec theta minus 1 by tan theta. Sec theta minus 1. Write it as 1 by cos minus 1 divided by sin by cos for tan. So this will become 1 minus cos theta divided by cos theta divided by sin by cos. Cos cos gets cancelled. 1 minus cos theta by sin theta. So 1 minus cos theta by sin theta. Again we can simplify it. 1 minus cos theta we have just seen. It is 2 sin square theta by 2. Sin theta is 2 sin theta by 2 cos theta by 2. You can cancel this 2 and 1 of the sine. So sin theta by 2 cos theta by 2 is tan theta by 2. So finally we got tan theta by 2 that we wanted, because outside it is tan inverse. So tan inverse tan theta by 2. Now you can just cancel it. Why? Because there is no boundary given. You can find out the direct answer. Theta by 2. What was theta? Remember, tan theta is ax. So theta will be tan inverse ax. Just write it here. 1 by 2 will be there. Theta will be tan inverse ax by 2. 2 is there. And tan inverse of anything will be 1 by 1 plus square of that thing. So dy by dx will be, this half will come outside. Tan inverse ax will be 1 by 1 plus this ax whole square. A square x square. And dy by dx of ax will be, because of the chain rule, it is going to be 1. So you get a by 2 1 plus a square x square. This is your final answer. Differentiate tan inverse sin x by 1 plus cos x. The x limit is given as negative pi to pi. So that will be used if we do certain substitution. So this substitution, if you are not substituting, then this range you don't have to worry about. But in case you are substituting, then this range becomes very important, as I earlier reiterated. So this sin x, that is sin 2 theta, is 2 sin theta cos theta. So sin x is 2 sin x by 2 cos by x by 2, that you can write. So this we can always change. 1 plus cos x, which is the denominator, this can be changed to 2 cos square x by 2. 2 gets cancelled. 1 cos 1 cos gets cancelled. So you just have sin x by 2 cos x by 2, that is tan x by 2. Now this is tan inverse of tan x by 2. So this tan and tan inverse gets cancelled. You have no substitution done. So y is basically x by 2. So you have to differentiate. You have to do dy by dx, which is equal to half. Differentiation of x is 1 only. So dy by dx is half here. This is your final solution. Differentiate sin inverse 1 by under root 1 plus x squared. So what we will do here is, we want something inside as sine. So this 1 plus cot square theta is equal to cosec square theta, that we already know. But the question is, you will ask, why are you not using 1 plus tan square theta, that will be equal to sec square theta? Why are you not using it? Because we have a sine inverse outside. So we need a sine inside, so that this sine and sine inverse can be cancelled. Of course, we can apply anything, but we have to solve the question. So this is 1 by x, I am putting it as cot theta. So 1 plus cot square theta, that is under root of 1 plus cot square theta. And this is 1 by 1 plus cot square theta is what? Cosec square theta. Under root of cosec square theta is cosec theta. So finally cosec theta will come. So let me write it as cosec theta. And we already know 1 by sin theta is cosec theta is 1 by sin theta. So it becomes sin theta. What is outside? It is sin inverse. Now since there is no limits being given or the boundary being given, you can always cancel these two out. So that is only theta will remain. But what is theta? We took cot theta as x. So theta was cot inverse x. So this theta, you can replace it by cot inverse x. And now we have to differentiate this cot inverse x. What is the differentiation of cot inverse x? Dy by dx of this cot inverse x is minus 1 by 1 plus x square. That is your final answer. Differentiate cos inverse 1 minus x to the power 2n divided by 1 plus x to the power 2n. So what we have to do for the inside thing, we need to come up with certain solutions so that cos comes. This comes with certain cos thing. So 1 minus x to the power 2n, you can always write it as x to the power n to the power 2. This is 1 plus x to the power n to the power 2. Now this x to the power n, you can replace it by certain thing like tan theta. So you get tan square theta and tan square theta numerator denominator. What I am trying to say is 1 minus tan square theta divided by 1 plus tan square theta, that is 1 minus tan square theta divided by 1 plus tan square theta is always cos 2 theta. That we know by trigonometric discussion we already had in the previous classes. So cos 2 theta is now, in terms of cos, we have a cos inverse outside. So it will be cos inverse cos of 2 theta. Now this you can cancel, you have a 2 theta. So how do we get theta here? Tan theta is x to the power n, theta is tan inverse x to the power n. So 2 into 10 to the power inverse x to the power n. So why is this? And there is, but before that, as I already told you, you have to check for the limit. The x range is what? 0 to infinity. That is, x is between 0 to infinity. What you have to check? You have to check for 2 theta, because that 2 theta is finally coming when you cancel cos and cos inverse. And that can only be cancelled when you have 0 to pi in between. So x to the power n, you just take the power of 0 to the power n, infinite to the power n, 0 to the power n is 0, infinite to the power n is infinite only. So 0, this is x to the power n, you can just write it as tan theta, and this is infinite. Now you can just take tan inverse on all the sides. So what do you get? Tan inverse 0 is 0. Tan inverse of tan theta is theta. So 0. Here you get theta. And tan inverse of infinity is of course pi by 2. So you can just write pi by 2 here. Now you need 2 theta. So you have to multiply this all by 2. Twice of this. So 2 into 0 is 0. Here you have 2 theta. And then twice of pi by 2 is pi only. Now since it is between 0 and pi, and cos inverse cos theta is theta only if you have theta between 0 and pi, which is actually the case here. So we have checked and verified it. Now we can easily differentiate 2 tan inverse x to the power n, which we came up just a few seconds back. Because we are into the limits, we are not gone out of the bound. So this is 2 tan inverse x to the power n. So dy by dx will be equal to 2, and we have tan inverse x to the power n. Tan inverse is simply 1 by 1 plus that content square. So x to the power n is there, so it is square x to the power 2n. Now differentiation of x to the power n is also to be done, which is simply n x to the power n minus 1. This is the basic differentiation formula. So what do you get? N x to the power n minus 1. The denominator you have 1 plus x to the power 2n, twice of this. Okay. So 2n x to the power n minus 1 by 1 plus x to the power 2n is the final answer. This is your dy by dx. Okay. Differentiate sin inverse 1 minus x square by 1 plus x square plus sec inverse 1 plus x square by 1 minus x square. Now this kind of question seems complicated, but just by one trick, one thing, this becomes so easy, you will not comprehend. See, this sec inverse and cos inverse are reciprocal. Sin inverse, cosec inverse, reciprocal. Tan inverse, cot inverse, reciprocal. Alright? So this is sec inverse 1 plus x square by 1 minus x square. So when you have sec inverse x, you can always write it as cos inverse 1 by x. And that is other way around also. That is cos inverse x is sec inverse 1 by x. So this sec inverse x can be written as cos inverse 1 by x. So cos inverse x will be sec inverse 1 by x. No. So this sec inverse x can be written as the reciprocal of whatever is inside. So you have sin inverse 1 minus x square by 1 plus x square, that is always there. Call it as theta, sin inverse theta, plus when you take sec inverse and when you convert it into cos inverse, this 1 plus x square and 1 minus x square, the numerator denominator will change the position. then it will be 1 minus x square by 1 plus x square. And sin inverse theta plus cos inverse theta is always pi by 2. That we already know. So what do we get? Y is simply pi by 2. So differentiation is dy by dx of pi by 2. Pi by 2 is a constant. It is going to be a 0. Differentiate tan inverse a plus x by 1 minus ax. So we have a, which is the one term, x as the other term. So we have the first term plus second term divided by 1 minus first term into second term. Now we know what kind of formula it will be. Because it is tan inverse outside, we need a tan inside. So that we can cancel it out. But here, we have a direct formula. Tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy. This we already know. So this is tan inverse. So this is a, say a and b. I'm just telling you the formula. If it is x plus y by 1 minus xy, that is simply equal to tan inverse x plus tan inverse y. Alright? So this is tan inverse x plus tan inverse y. Alright? So tan inverse x plus y by 1 minus xy is this. So tan is actually coming in picture, which we want. We want tan to come in picture. So this one is a and x. So it will be tan inverse a plus tan inverse x by the analogy of the formula which we just discussed. So tan inverse a plus x by 1 minus ax is tan inverse a plus tan inverse x. There are two terms a and x, which is fulfilling the criteria of this kind of trigonometric identity or equality. So tan inverse a plus tan inverse x, you just have to differentiate it. Why is this? When you differentiate d by dx of tan inverse a is a constant, it will be a 0 only. You have to have a x to differentiate with respect to x, of course. Now tan inverse x, differentiation of this is 1 by 1 plus x square. So y is equal to 1 by 1 plus x square. This is your final answer. So because we have not changed anything, no substitution, no limits, no boundaries, so it's the final answer. Same thing here. Tan inverse under root x plus under root a divided by 1 minus this under root x into a can be written as under root x into under root a. This can be written as under root x into under root a. So this is your p, assume it to be p plus q by 1 minus p into q, and that is equal to tan inverse p plus tan inverse q, which we have just seen in the previous question. And the p and q is under root x and under root a. So it will be tan inverse under root x plus tan inverse under root a. Alright? So dy by dx it is going on. So d by dx of tan inverse under root x plus dy by dx of tan inverse under root a. Since this dy by dx of under root a is going to be 0, whatever tan inverse it is, we just have to worry about dy by dx of tan inverse under root x. That is the final answer. And this is by 1 plus under root x whole square. Under root x square is x only. So you have 1 by 1 plus x. And dy by dx of under root x also we have to do. And root x differentiation is what? 1 by twice of under root x. So you just write 1 by twice of under root x. So we have 1 by twice of under root x, and inside this we have 1 plus x. Okay. So this solution I have provided just to know that this is how you are going to write. I always tell the logic and reasoning of the answer, how you are going to solve, but in examination you have to write it like this. Now this tan inverse a plus b tan x, b minus a tan x. So most of the questions which are coming just after this is all about converting certain thing so that you get a tan inside. Because tan inverse is also outside, you need somehow tan inside. Okay. So this a plus b, I am taking the inside one, a plus b tan x divided by b minus a tan x. So how to resolve this? We can divide the numerator denominator by b. A by b, b by b, b by b, a by b. Now this a by b, let it be like this, a by b. And this b by b gets cancelled, this also b by b cancelled. So this is 1 and 1. So finally a by b plus tan x, 1 minus a by b into tan x. Okay. So tan inverse, this will get cancelled. So the inside one, which is this, we have to come up with some tan sort. So we have tan inverse A by B. I am writing A by B as tan inverse A by B because tan and tan inverse gets cancelled. So A by B can be written as tan inverse A by B. This is very important to understand. Again, in the denominator, A by B, in place of A by B, I am writing it as tan into tan inverse A by B. Tan x is already there. So eventually this tan inverse A by B is A by B only. We have changed this because this first term plus second term divided by 1 minus first term into second term, that is P plus Q divided by 1 minus P into Q, is nothing but tan of P plus Q. What is P here? Tan of this tan inverse A by B is P, that is the theta inside. And the second theta is x. I hope you got the idea. It will be tan inverse A by B, because the first theta is tan inverse A by B. The second theta is x. Whatever is inside tan inverse is your theta, of course. So it will be tan inverse A by B plus x. So this content is the first angle, the second angle is x. So this will be tan inverse A by B plus x. So you already have a tan inverse outside, cancel this out. So what it is remaining, tan inverse A by B plus x. Now you can just differentiate it, dy by dx. Tan inverse A by B is what? 1 by. See, tan inverse A by B is, you don't have to worry about this because this is a constant. Constant differentiation is 0. But don't worry about that, it will be 0. Only differentiation of x is going to be 1. So dy by dx is 1 only. Differentiate tan inverse A plus bx by b minus ax. So I hope if you understood the previous question, this is a piece of cake for you, because A plus bx divided by b minus ax, which is inside, we need to divide it by b. This also b, this is b, this is b, and this is b. So this is A by b plus bb gets cancelled. You have x here. The b by b is 1 minus is there. And then we have A by b x. Same thing here. This, see, tan inverse is already outside. And this is corresponding to tan inverse x plus tan inverse y. What is x? A by b. What is y? Which is x. If I just take some random p and q, this p plus q by 1 minus p into q is tan inverse p plus tan inverse q. Okay, you got the idea? So tan inverse A by b, it will be tan inverse A by b plus tan inverse x. That is your final result in this case. Okay. So this tan inverse A by b plus tan inverse x is y, dy dx of y. This becomes 0. Tan inverse A y will be 0. And tan inverse x differentiation is of course 1 by 1 plus x square. This is dy by dx. Alright. This is your final answer. Differentiate tan inverse x minus a by x plus a. Okay. So for this, again, divide it by x so that you get a relation in terms of tan, because tan inverse is already outside. So let us divide the numerator denominator by x. So what do you get? 1 minus a by x divided by 1 plus a by x. So we assume that it is 1 into a by x. The first one is 1. The second one is a by x. When you have tan inverse outside this, what does it mean? It is simply tan inverse of first term, which is 1, minus tan inverse of a by x. Remember, it is negative in the numerator, denominator it is positive. So now it will be tan inverse 1 minus tan inverse a by x. Now this is y. Now let us differentiate it, d by dx of this. So this is a constant, tan inverse of 1 is constant, it will be 0. And tan inverse a by x, it is simply 1 by 1 plus a by x whole square. And then differentiation of a by x, d by dx of a by x. So this is going to be 1 by 1 plus a by x whole square, which is x square plus a square by x square goes up. Differentiation of a by x a will be constant, so it can come out. 1 by x is minus 1 by x square. Okay, so finally it will be, this denominator will be, see, 1 plus a square by x square is x square plus a square. This x square goes up. So it will be, finally this result will be x square by a square plus x square, or x square plus x square, a square. A is already there. And since we have negative, there is a negative sign also, because tan inverse 1 was 0, remember? So we have a negative from differentiation of a by x. We have a negative outside also. So negative becomes positive. This is negative and this negative. So it becomes positive. So you have this a by x square plus a square. That is going to be your final answer. Okay. Differentiate tan inverse x by 1 plus 6x square. You need tan inside, or whatever formation you can make, so that you get a tan inverse relation. 6x square is 6 into x square, can be written as 6 into x into x. 6 can be written as 2 into 3, x into x. So this is 3x into 2x. 3x into 2x is 6x square. Okay, what is the use? Because the numerator is x, and x can be written as 3x minus 2x, and that is going to be x. So in place of x, I am replacing it by 3x minus 2x. The denominator, it is going to be 1 plus, it is not negative plus. Okay, I'll just change it. 3x into 2x, 3x into 2x is 6x square. So you have a tan inverse outside, and you know by up till now what we have done. It will be tan inverse 3x minus tan inverse 2x, because tan inverse x minus tan inverse y is tan inverse x minus y by 1 plus xy. Right? So this is the relation, you have to remember it. So tan inverse 3x minus tan inverse 2x, we have to differentiate. This is your final thing. Let's differentiate it. So why is this? d by dx of these two. So tan inverse 3x is 1 by 1 plus 3x whole square. And differentiation of 3x is 3 only. d by dx of 3x minus d by dx of, so we have 1 plus 2x whole square, and d by dx of 2x, 2x it is. So this 1 by 1 plus 3 is a 9, 9x square it will be, and d by dx of 3x will give you 3 only. So 3 in the numerator, minus d by dx of 2x is x only, 2 only, and 1 by 2x whole square is 4x square. This is your final answer. You know, if you solve it, that will not be a very good idea, because you are not going to gain anything. This is your final answer. Alright? Now we have to differentiate this tan inverse 5x divided by 1 minus 6x square. So this type of question we have just done, that there is also a limit being given, or the boundary being given. X should be between this and this, minus 1 by root 6 and plus 1 by root 6. So if you are not substituting anything, don't worry about the limit being given here. So we have tan inverse a plus b divided by 1 minus ab. Whenever this is the case, it is simply tan inverse a plus tan inverse b. So this is the say equality which we are going to employ in this question. Tan inverse 6x square we have here. 6x square can be written as 6 into x into x. 6 can be written as 2 into 3 into x into x. Okay. So this can be written as 3x into 2x. Basically 6x square can be written as 3x into 2x. Because 3x plus 2x, when we add, it will form 5x. 3x plus 2x is 5x. So 3x plus 2x here, 1 minus 6x square will be written as 3x multiplied by 2x. This is your a, this is your b. So a plus b divided by 1 minus a into b, and that will be equal to tan inverse a plus tan inverse b. A is 3x here and b is 2x here. That is why I told you the equality earlier, so that we directly put tan inverse 3x plus tan inverse 2x here. Okay, so this is why. when we take dy by dx, tan inverse of anything, the differentiation is 1 by 1 plus square of that thing. So 1 by 1 plus 3x whole square. So this 3x differentiation is 3. Tan inverse 2x is 1 by 1 plus 2x whole square. And differentiation of 2x is what? 2. So this is the final. And 3x square is 9x square. And 2x square is 4x square. So just keep it like that. X is between certain two values. And we are not substituting anything. So don't worry about this limit. Okay. Try to make this inside thing. Something comes out of it which should contain a tan. Because outside we have a tan inverse. So let me write this cos x plus sin x and divided by cos x minus sin x. So how can we make something out of it so that it contains tan? Divide numerator denominator by cos x. So cos x here, here also cos x, here also cos x. So do you get 1 plus sin by cos is tan x. Then this is 1 minus tan x. Now you know how to do this because you know that tan a plus tan b by 1 minus tan b is tan a plus b. And tan pi by 4 is 1. For tan 45 degrees 1. So in place of this 1 I am writing tan pi by 4. The denominator, assume this to be 1 into tan x. It is actually 1 into tan x. So tan pi by 4 plus tan x divided by 1 minus tan pi by 4 into tan x. So what do we get? Because this is tan inverse outside. And what is inside? Tan a plus tan b by 1 minus tan a tan b is tan a plus b. So you have tan pi by 4 plus x. So this is tan a plus tan b, 1 minus tan a tan b is tan pi by 4 plus x. Tan inverse is outside. Now since there is no substitution being done, only we have simplified or we have converted this expression inside so that this tan comes out, tan inverse gets cancelled. Pi by 4 plus x, this is y. And dy by dx is simply the differentiation of this pi by 4 plus x. This is a constant, so it is going to be 0. Differentiation of x is going to be 1. Differentiate tan inverse x raised 1 by 3 plus a raised 1 by 3 divided by 1 minus a into x raised to the power 1 by 3. So x raised a by 1 by 3 and a raised 1 by 3. The denominator is ax into 1 by 3, which is essentially equal to a raised 1 by 3 multiplied by x raised 1 by 3. So let us separate it so that we get certain of that sort which we have already seen. For example, assume it to be p plus q by 1 minus p into q. If you have certain thing like this, it's basically an tan of something. That is tan inverse a plus tan inverse b. When you have tan inverse of say p plus q by 1 minus p into q, it will be tan inverse p plus tan inverse q. What is p here? X to the power 1 by 3. What is q here? It is a raised 1 by 3. So tan inverse x to the power 1 by 3 plus tan inverse a to the power 1 by 3 and divided by, this thing comes as tan inverse a plus tan inverse b. So this is how this formula we have been using and utilizing a lot. So now it will be clear to you. So you just have to differentiate this dy by dx. Tan inverse a raised 1 by 3, there is no x, so it is going to be 0. It is considered as a constant. And then we have 1 plus x to the power 1 by 3 whole square, because tan inverse of anything differentiation is 1 by 1 plus square of that thing. Differentiation of x raised 1 by 3 by product rule, the chain rule. So we have this 1 by, x to the power 1 by 3 differentiation let us do first. X raised n differentiation is n x to the power n minus 1. So you have 1 by 3 x to the power 1 by 3 minus 1. It is going to be minus 2 by 3. So since it is a negative, you can bring it down to the denominator. So it will be 1 by 3 into x to the power 2 by 3. So this is in the numerator, you can bring it down. So final answer will be 1 by 3, 1 plus x to the power 2 by 3, and this is in the denominator, so 1 by x to the power 2 by 3. Okay, this is final answer. Differentiate sine inverse 1 by under root 1 plus x square. So we will just substitute something inside this under root 1 plus x square so that we get something out of it, so that we get sine. So this is equivalent to under root a square plus x square. This under root 1 plus x square is under root a square plus x square. A is 1 here, x is x only. So x can be written as cot theta, x can be written as the tan theta. Why? Why we are not putting x as tan theta? Why we are putting as x equal to cot theta? Just because we have a sine inverse outside. We need something inside that results in something with sine. And that can only be retrieved only when we have x equals cot theta. So when you put x as cot theta, the inside thing goes under root 1 plus cot square theta. 1 plus cot square theta is what? 1 plus cot square theta is cosec square theta. From here x is cot theta, so x will be equal to cot inverse x. 1 plus cot square theta is cosec square theta. And since we have the root of cosec square theta, you are going to get cosec theta. If you take the under root, it will be cosec theta only. And cosec theta is what? 1 by sine theta. Or you can say sine theta is 1 by cosec theta. One and the same thing. So finally, the inside thing, which is 1 by under root 1 plus cot square theta. Under root 1 plus cot square theta is under root cosec square theta, which is going to be equal to cosec theta, and cosec theta is 1 by sine theta. So sine theta will go up. So finally we will get sine theta inside. Now there is no substitution, so you can just cancel these two out. So finally you have to differentiate theta. What is theta? Theta is cot inverse x. And cot inverse x is minus 1 by 1 plus x square. This is dy by dx. Okay. If y is equal to this, x should be between 0 and 1. You have to prove dy by dx is 4 by 1 plus x square. One time we have sine inverse, one time we have sec inverse. So let us put something in this x so that this sine inverse also get it to be solved, and sec inverse also gets something out of it. So one is this, the inside one. If we put x as tan theta, it will be 2 tan theta divided by 1 plus tan square theta. And this is nothing but sine 2 theta. We already know it. Then this one, 1 plus x square by 1 minus x square. Now if you put this as x as tan theta, it is going to be 1 plus tan square theta by 1 minus tan square theta. But we know 1 minus tan square theta divided by 1 plus tan square theta is going to be cos 2 theta. So there has to be some reciprocal here in order to get cos 2 theta. But we have a sec inverse outside. So we need to convert this sec inverse into cos inverse so that we get the reciprocal of inside thing, and then that ultimately gives you cos 2 theta. Because sec inverse x is cos inverse 1 by x. Or you can say cos inverse x is 1 by sec inverse x. So when you convert this sec inverse into cos inverse, the numerator and denominator will change position. So 1 minus tan square theta by 1 plus tan square theta. This is cos 2 theta. So cos 2 theta for second, and for 1 sin 2 theta. Now replace it. Sin inverse sin 2 theta plus sec inverse we already converted into cos inverse. and inside thing will become cos 2 theta, as I just explained you. Okay, so cos inverse with cos 2 theta. Now just cancel these two out, so 2 theta plus 2 theta, and this is going to be 4 theta. Theta, you can replace it by tan inverse x. X is tan theta, so theta will be tan inverse x. So 4 into tan inverse x. So this is y. Now let us differentiate it. So this differentiation, before you remove the sine and sine inverse, that will has to be minus pi by 2 and pi by 2. And this again, this 2 theta has to be between 0 and pi if you want to cancel it this cos and cos inverse out. X is between 0 and 1. So let us use it. X is between 0 and 1. X is what? Tan theta. So tan theta and 0 and 1. Now apply this tan inverse, or find out the value of 0 and 1 when we have a tan. So theta will be equal to, means it is between pi by 4. 0 is of course pi by 0. Now we need 2 theta, so multiply 2 everywhere. So 2 theta will be 2 into 0 is 0 only, and 2 into pi by 4 is pi by 2. So 2 theta is between 0 and pi by 2, and which is there between 0 and pi and minus pi by 2 and pi by 2. So we don't have to worry about. So we just have to differentiate this. dy by dx is 4 tan inverse x. Differentiate this 4 into tan inverse x. That is 4 into 1 by 1 plus x square. So dy by dx we have to prove it to be 2 by 1 plus x square. X is between 0 and infinity. So you know by now how to check, how to do this. So I will directly do the solution without checking the 0 and infinity of x, the range. Because you know sin inverse sin theta will give you theta only between minus pi by 2 and pi by 2. Cos inverse cos theta will give you theta only when theta is between 0 and pi. So we'll put something here so that we get a sin inside. Here also we put something so that we get a cos inside. So this x is equal to tan theta we are going to replace. This is 1 and 2. So let us take 1, this x by 1 plus x square. So I am replacing it by tan theta by 1 plus tan square theta. This is our first one. Second one is inside, what is inside cos inverse? We have 1 by under root 1 plus tan square theta. So tan theta is sin theta by cos theta. Under root 1 plus tan square theta, under 1 plus tan square theta is sec square theta. And under root of sec square theta is going to be sec theta. And what is sec theta? It is 1 by cos theta. So just use 1 by cos theta, cos gets cancelled, you get a sin theta here. 1 plus tan square theta again is sec square theta. Under root of sec square theta is sec theta, so you get 1 by cos theta. So basically cos theta you will get. So what will be the final thing? Sin inverse sin theta plus cos inverse, and this is cos theta. Now if you want to cancel these two, you know these steps, and I'm just skipping this step because you know up till now how to do this. So theta plus theta will remain, it is going to be 2 theta. Y is equal to 2 into theta was what? Tan inverse x. So 2 into tan inverse x, 2 differentiation of tan inverse x is 1 by 1 plus x square. So y is equal to 2 by 1 plus x square is your final answer here. This one. Differentiate the following with respect to x. So you have a cos inverse sin x. The whole idea is to convert this sin into cos so that this cos and cos inverse can be cancelled. The whole idea is that. Okay. So how to do this? Cos pi by 2 minus x is sin theta. Sin x that is. And sin pi by 2 minus x is cos x. And there are the relationship between tan and all these cot, sec, cosec like that. So let us convert this sine into cos by this. So cos 90 minus theta is sin theta. So in place of sin theta, just write cos 90 minus theta. So cos inverse cos pi by 2 minus x it will be. Okay. So you just cancel it out. Pi by 2 minus x will remain, and this is your fx, which is y. So dy by dx is equal to pi by 2 is 0, and minus x, differentiation of x is going to be 1. So negative 1 it will be. Differentiate the following with respect to x. So you will be tempted to put something in place of x and trying to differentiate. That is also a way. The second way is directly doing it. Apply cot inverse formula of differentiation. Okay, rather than putting x somewhere. So cot inverse x is tan inverse 1 by x, or you can say tan inverse x is cot inverse 1 by x. So when we convert this cot inverse into tan inverse, it will be simply the numerator denominator will exchange the position, or it will be a reciprocal. So 1 plus x will go numerator, 1 minus x will go denominator. Okay. Now again you can place x as something, and you know that 1 can be converted to pi by 4, and denominator minus x can be converted into minus 10 by 4 into x. Then you have this formula is easy that we have seen. But rather than doing this, as I said, tan inverse theta differentiation, or tan inverse anything is differentiation, is 1 by 1 plus square of that thing. Okay, so this is tan inverse of whatever is inside, 1 by 1 plus of square of that thing, which is 1 plus x by 1 minus x in this case. Now differentiation of this is also to be done by the chain rule. So it will be differentiation of 1 plus x divided by 1 minus x. We just have to solve this first one and then differentiation of the second one. So let us do the differentiation of the second one. D by dx of 1 plus x by 1 minus x. So 1 minus x whole square in the denominator. So I'm using the quotient rule here. 1 minus x will be here, d by dx of 1 plus x will be, let us do it here, 1 plus x, 1 will be 0, x will be 1, so 1 only. Minus 1 plus x will come outside, and differentiation of 1 minus x. Differentiation of 1 minus x will be what? Differentiation of 1 is 0 and x is 1, so negative 1 will come out. So negative will become plus. So this x gets cancelled, 1 plus 1 is 2. So you have 2 by 1 minus x square. Finally you get a differentiation as this one. In the front we have 1 by 1 plus x by 1 minus x whole square. So we have to solve this also. So I am doing the denominator first. 1 by 1 plus x whole square, 1 minus x square. So 1 minus x square plus 1 plus x square, I am taking the LCM, divided by 1 minus x square. Now remember, this was in the denominator. This was in the denominator, but that is 1 by this thing. So when you actually write it, this 1 minus x square will go in the numerator. So 1 minus x square, this is 1 by, okay. So 1 minus x square divided by 1 minus x square. Assume it to be, say, some p term. Total term is p. And this we already done twice by 1 by 1 minus x square. Cancel this 1 minus x square. So twice of 2 divided by p. What is p? So this solution you have to put in here. So let us open this 1 minus x square plus 1 plus x square. So a minus b whole square is a square plus b square minus 2ab. And this 1 plus x whole square is 1 square plus x square plus 2x. 2x cancel. So this is going to be 2 plus 2x square. 2 common you can take, 1 plus x square. And denominator you have 2 into 1 plus x square. 2 gets cancelled. You have 1 by 1 plus x square. That is going to be your final result. Y is equal to cot inverse. There is a content inside. You have to show that dy by dx is independent of x. This we'll talk later, because you'll see the answer will not contain x. The basic thing is you need a cot here. Tan also can solve the problem, but preferably it should be cot. Alright? So we need to rationalize it. So in order to make you understand, let me call it as p. This as q. 1 minus sin x is q. 1 plus sin x is p. So under root p plus under root q, that is divided by under root p minus under root q. Okay. In order to rationalize, you have to multiply the numerator and denominator by under root p plus under root q, because we need a squared minus b squared kind of thing in the denominator, so that we get rid of the roots. So we are multiplying this, rationalizing it. The numerator will be under root p plus under root q whole square, and this a plus b, a minus b kind of thing, it will be a squared minus b squared, that is under root p whole square minus under root q whole square. So ultimately you will get p minus q. And what is p? P was 1 plus sin x. And what was q? It was 1 minus sin x. Now let us open this. 1 plus sin x minus 1 plus sin x. You can cancel these two. So the denominator will be 2 sin x. So we'll use this denominator in a short while. Let us resolve the numerator first. So it is under root p plus under root q whole square. A plus b whole square. So under root p whole square will be p. That under root q whole square will be q. And that's twice of under root p into under root q. So p plus q plus twice of. So this under root p into q, that we will just solve. P plus q is what? 1 plus sin x plus 1 minus sin x. This is p plus q. And plus twice of under root pq, I will just do it. So this 1 minus sin x and 1 plus sin x, let us multiply this. P was 1 plus sin x and q was 1 minus sin x. So you get a squared minus b squared, 1 square minus sin square x, and 1 square minus sin square x, 1 minus sin square x is cos square x, because cos square plus sin square is 1. So this under root cos square it is. Final will be cos x only. So this gets cancelled. You have 2 plus twice of cos x. And remember, what was the denominator? It is 2 of sin x, twice of sin x. So let us write it here, twice of sin x. Now 2 you can take out, 1 plus cos x, and denominator you have 2 sin x. 2 gets cancelled. 1 plus cos x is 2 cos square, whatever theta is there, it will be theta by 2. So it will be 2 cos square x by 2. And sin x is sin theta, sin 2 theta is 2 sin theta cos theta. So here it is 2 sin x by 2 cos x by 2. Cos cancel, 2 cancel. It will be cos x by 2 by sin x by 2, which is equal to cot x by 2. So we have cot x by 2 here. Cot inverse was already out. So you can just cancel it out. It will be x by 2. So this is why dy by dx is simply half will be here. D by dx of x is 1. So the final result is half. That means that it is independent of x. Differentiation is independent of x. There is no x here. Okay. If you remember, this kind of question we have already done. And so this kind of question we have already taken. I am just skipping it because you know how to do this. For your reference, I am giving you the solution so that you can do it one more time. This is also, this sec inverse has to be made as cos inverse, and sin inverse theta plus cos inverse theta is simply pi by 2. This already we have done. Just for your reference again, I am giving you the solution here. So we have to find out dy by dx, and that will be 0 here in this case. Sin twice of tan inverse under root 1 minus x divided by 1 plus x. This under root is total, okay? It is both the num and den, that is numerator denominator, are inside the under root. So what do we take? Because we need a tan inside. Okay? Just see the content. So if we put x as cos 2 theta, what do we get? 1 minus cos 2 theta divided by 1 plus cos 2 theta. This is 1 minus cos 2 theta is simply 2 sin square theta. 1 minus cos 2 theta is 2 sin square theta. And 1 plus cos 2 theta is 2 cos square theta. 2 gets cancelled. It will be tan square theta. Since it is inside the under root, it will be tan theta. And as I told you earlier, what do we need? We need a tan theta, of course. So you have sin twice of tan inverse, and then we have tan theta. Now you can just cancel this tan and tan inverse. So what is theta? So we have sine twice of theta. Theta from what we have substituted x is cos 2 theta. So this will be cos inverse x is twice of theta, and theta will be equal to cos inverse x, half of cos inverse x. So you have sine twice of theta is half of cos inverse x. So 2 you can cancel, and you have sine of cos inverse x. Now you know that there is a relationship between cos inverse and sine inverse. What is that? Cos inverse x is equal to sine inverse under root 1 minus x square and vice versa. That is, cos inverse theta or cos inverse x is equal to sine inverse 1 minus x square. Alright? So the same thing with these, if you want to substitute it for other questions also, same kind of equality exists. So you have sine, in place of cos inverse x, replace it by sine inverse under root 1 minus x square. Now you can just cancel these two out. They are just inverse of one another, so you can just cancel them out. Okay. Now, what do we get here? Under root 1 minus x square. Why is under root 1 minus x square? So you have to differentiate this. It is simply 1 minus x square to the power half. So it will be half 1 minus x square to the power half minus 1. Half minus 1 is negative half only. So 1 minus x square also will be differentiated because of the chain rule. It will be minus 2x. So what do you get? Half. This will be negative half. So this, when you take it to the denominator, it will be 1 minus x square to the power minus half. Will become plus half. So that is root only. So 2 gets cancelled. You have minus x divided by under root 1 minus x square. Okay. Y is equal to cos inverse 2x plus twice of cos inverse under root 1 minus 4x square. X is between 0 and half. This is dy by dx, you have to find out. So first we'll try to solve everything. We'll come up with a solution. And then I'll tell you whether we are correct or not, because the range is given. 0 to half x has to be. So we need a cos here. We need a cos inside. Here also we need a cos. Both sides we need a cos. Okay. So let us take this. We'll check just this x between 0 and half. We'll just check in a short while. So we'll put 2x as cos theta. When we put 2x as cos theta, it will be cos inverse cos of theta twice of cos inverse under root. Now 1 minus 4x square, let us take this. 1 minus 4x square can be written as 2x square, and 2x is nothing but what? Cos theta. So it will be under root 1 minus cos square theta. 1 minus cos square theta is sin square theta. And under root of sin square theta will be equal to sin theta. Alright? So you can write it as sin theta. But in order to cancel these two, you need cos, this sin in terms of cos. Because cos 90 minus theta is sin theta, sin 90 minus theta is cos theta. So you can replace this sin theta by cos pi by 2 minus theta. So let me cancel these two first. Cos and cos inverse gets cancelled. I'll tell you the limits just now. So it will be theta, and sin theta we are putting it as cos pi by 2 minus theta. So cos inverse you can cancel, plus 2 into plus twice into pi by 2 minus theta. So that will be 2 pi minus 2 theta. So we have 2 pi minus theta. Final will be pi minus theta. Sorry. So that will come, but we'll just see. So here you will get 5 pi by 2 minus theta. So you have to check for two things: the theta is correct or not, and pi by 2 minus theta is correct or not. And for sine or cos, you know, cos and cos inverse can only be cancelled when you have the theta belonging to 0 to pi. So what do we get here? Let us solve this first. So you have pi minus theta that you have to differentiate. Y equals to pi minus theta. Pi minus theta will be equal to what? It will be cos inverse 2x. So put it here. Cos inverse 2x. Because 2x was already taken as cos theta. Now before we actually differentiate it, we have to check for theta and pi by 2 minus theta. X is given between 0 and half, 1 by 2. Now, what is the value? 2x it is. So you have to use 2, multiply 2 everywhere. You get 0, 2x, and 2 into 1 by 2 is 1 only. So cos theta will be equal to, is between 0 and 1. So if you take cos inverse, this 0 will be 0. It will be theta, and this will be equal to pi by 2. So theta is between 0 and pi by 2. Don't worry about that, because we need to have just 0 and pi. Theta belongs to that. So 0 and pi by 2 is inside 0 and pi. Now pi by 2 minus theta. So when you have minus theta, see, we'll use just this result, because theta is between 0 and pi by 2. When theta is between 0 and pi by 2, let me write it here. 0 is between 0 and pi by 2, inside we have theta. Now you need pi by 2 minus theta. So let us multiply everywhere with negative 1. So all the inequality will change. Minus theta, here also minus pi by 2. Now we need pi by 2 minus theta, so just add pi by 2 everywhere. Pi by 2 you add here also you add pi by 2. Okay, this is pi by 2, this is going to be pi by 2 minus theta, and this is going to be 0. Again, pi by 2 minus theta is again in between 0 and pi. It is between 0 and pi by 2, and we needed it for 0 to pi, and then that is also correct. Now let us take dy by dx. Pi will be 0. Cos inverse 2x will be, cos inverse 2x, cos inverse theta is actually minus of 1 by under root 1 minus whatever is after the cos inverse, right? So you have two negatives, one negative outside, one negative coming from the differentiation. So minus 1 by under root 1 minus 2x whole square. So then the differentiation of 2x will give you 2. So minus minus plus twice of under root 1 minus 4x square it will be. This is your dy by dx. This is your final answer. Okay. If the derivative of tan inverse a plus bx takes the value of 1 at x equals 0, prove that 1 plus a square is equal to b. Now, at x equals to 0, the differentiation of this particular thing will give you some value. And that value have to be the last one, 1 plus a square equals b. Okay. So tan inverse, what do we need inside? Something tan. But the better way is to solve it normally. Tan inverse of dy by dx of tan inverse is 1 by 1 plus the content square, that is a plus bx whole square. And then the differentiation of a plus bx will also be done, because this is what we call as chain rule. So a plus bx differentiation dy by dx of this, a is 0 and here x is 1, so b. B will come. This is your final differentiation. Now it takes the value of 1 at x equals to 0. So this is equal to 1 when x is equal to 0. So now put x equals to 0, you get b by 1 plus, if this is 0, it will be a square. 1 plus a square is equal to 1. So b will be equal to 1 plus a square. And that is what we have to prove. Okay. Y equals cos inverse 2x plus 2 cos inverse under root of 1 minus 4x squared. X is between minus half and 0 and dy by dx. Now you will realize in this question, if you don't consider the periphery or the limit or the range, what will be the problem? I will solve it normally first, but the answer will not be correct. You'll see that. Then I'll correct it. So what do we need inside? Because it is cos inverse, by default we need some cos inside. So we'll put 2x equals cos theta. So it will be cos inverse. 2x we have taken as cos theta plus 2 cos inverse. And this is under root 1 minus 4x square. So it will be 1 minus, you can write it as 2x whole square, it is 4x square only. 2x we are putting as cos theta. So 1 minus cos square theta it will be. So 1 minus cos square theta is sin square theta. And there is a under root, so sin theta will come out. And since we don't need a sin theta here, we need a cos theta. So you can always convert a sin and cos. Sin 90 minus theta is cos theta. Cos 90 minus theta is sin theta. So cos pi by 2 minus theta is sin theta. So in place of sin theta, we are going to replace it by cos pi by 2 minus theta, which is nothing but cos 90 minus theta. So cos 90 minus theta it will be. Now you can just cancel it out. Beware, I am just doing it. So cos inverse I cancelled, here also cos inverse I cancelled, theta plus twice into pi by 2, that is pi minus 2 theta. So pi minus theta will come. But you will see just now, it is not going to come. See, we have done a question like this. Pi minus theta came, we checked for the periphery, that is minus half x 0 in this case. In the earlier cases also we checked. But here, there will be, we are running out of it. That is, we are going out of bounds. You'll just see now. So pi minus theta will come. That we have to differentiate. But in a short while, you will see that this is not correct way to do it. This will be wrong. The solution will be wrong. Okay. Just bear with me. This is x is between negative half and 0. Alright. What is the angle? Theta and pi by 2 minus theta. So we are going to check for both of it. So when we cancel cos and cos inverse, the theta has to be between 0 and pi. That we already know. For sine, it was 0 to pi by 2. So if you want to cancel cos and cos inverse, the theta has to be between 0 and pi. That we already know. So let us check it here, because we are checking for 2x, because x is there. So multiply everything with 2x. 2x is cos theta. We have to check for theta. Okay. So what will be the left and right hand side? If you take just theta, it will be, see, it will be cos 0 is 1, cos 0 is 1, cos 90 is 0. So this is basically pi by 2. When you take cos inverse of 0, it's going to be pi by 2. Right? But when you take the minus 1, okay, it is going to be pi. Alright? Cos 180 degree we are talking about. Cos 180 degree, if you take 0 on the right, just imagine 0 and then completely shifting. So it will be pi. So what do we get? This range is between pi and pi by 2. But we wanted the range between what? 0 to pi, and it is inside that. Pi and pi by 2 range is between 0 and pi. So don't worry about that. Now let us come to the second part. Now this is already with us. Theta, so we will multiply negative every side, so it will be, the inequality will change. Then we add pi by 2, because we have to check for pi by 2 minus theta. So we are adding pi by 2, and this is minus pi by 2 on the left, right it is 0. But now we have gone from 0 to negative pi by 2. The range of cancelling cos and cos inverse is simply minus this 0 to pi. If I just explain it in a vague way, 0 to pi is on the right, 0 to negative pi by 2 is on the left. So when you go to the left, you cannot just put pi by 2 minus theta as like that. When you cancel cos and cos inverse, you have to have a negative there. If you are between 0 and pi, no trouble. Cos and cos inverse will give you theta. But if you are between, say, for example, in here, 0 to minus pi by 2, you cannot just cancel cos and cos inverse and you can write it as theta. No, it is negative theta. It is negative theta. So when you cancel the second part, cos and cos inverse, I am writing it again. I told you I will do it wrong first and then I'll tell you what will be the right thing. It is not pi minus theta. Theta is there. This is negative of pi by 2 minus theta. Okay. So when you multiply 2, it will be theta minus pi minus 2 theta. So when you open it, it will be 3 theta minus pi or minus pi plus theta. So this is what you have to differentiate, not pi minus theta, which we have done earlier in certain questions. Do you have a dx of negative pi? Negative pi is constant, so it will be 0. 3 theta. Theta is what? Cos inverse 2x. It is cos inverse 2x. Now when you differentiate this, 3 cos inverse 2x is what? Cos inverse differentiation is negative 1 divided by under root 1 minus the content square. So 1 minus 2x square 4x square it will be. Then the differentiation of 2x will also be done. It will be 2. So what do you get? 3 into 2 into minus 1, negative 6 divided by under root 1 minus 4x square. This is the correct answer. This becomes very important, especially for those who are preparing for a competitive exam. This has to be taken care. For board, it might not be that important, right? Y is equal to tan inverse of some content. Find dy by dx. So ultimately, you know that we need a tan inside. So how to put certain things so that we get rid of this under root and all this. X I am putting as cos 2 theta. So 1 plus x, under root 1 plus x will become under root 1 plus cos 2 theta. 1 plus cos 2 theta is 2 cos square theta. And this is under root 2 into cos theta, that will come out. Now under root 1 minus x, under root 1 minus cos 2 theta it will be. 1 minus cos 2 theta is 2 sin square theta. Under root 2 sin square theta. So under root 2 will come out and sin theta will be there. So what do we got? Let me replace it here. I am just taking the inside thing. I am replacing this under root 1 plus x by under root cos theta minus this as under root 2 sin theta divided by under root 2 cos theta plus under root 2 sin theta. Under root 2, you know, it's common, you can take it outside and cancel it. This all gets cancelled out. So what I'm trying to suggest is root 2 I have taken numerator denominator common and cancelled it. So what does remain is cos theta minus sin theta divided by cos theta plus sin theta. But still we need a tan. So we haven't yet reached the solution. We need to have certain things so that we get tan. So in order to do that, we'll divide the numerator denominator by cos theta. So I'm dividing cos theta everywhere, all the terms. So this becomes 1, and this also 1. 1 minus sin by cos is tan, 1 minus tan theta, and this will be 1 plus tan theta. Now how to make it as tan? We know tan pi by 4, tan 45 degrees is 1. So this, in this place I am going to replace it by tan pi by 4. I am assuming this to be tan theta into 1. Again replacing 1 by tan pi by 4. So finally it became tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 into tan theta. And what is this? That is tan A minus B. A is what? Pi by 4. B is theta. So it will be tan pi by 4 minus theta. Now we have come to tan. We started with this inside thing and we wanted some tan thing to come. And tan inverse is outside. So now we will cancel this tan and tan inverse. And you'll see this pi by 4 minus theta is what we have to differentiate. What is theta here? Cos inverse x twice theta. So theta will be half of cos inverse x. So essentially pi by 4 minus half of cos inverse x we have to differentiate. Because x was cos 2 theta we placed initially. Let us differentiate it d by dx. So d by dx of this content pi by 4 will be 0 minus half. Cos inverse is negative divided by under root 1 minus x square. Minus minus become plus. So it will be 1 by twice of under root 1 minus x square. That's your final answer. You have to write like this, okay? Everything has to be written because you have to explain the examiner that you know everything. Whatever steps you have followed, you have to write it properly. The logic, leave it to me. I'm going to guide that. In this question, there is a small trick, and that trick, it's not a trick basically, it's basically has come from trigonometry. We have been doing this kind of thing in trigonometry, but here we'll apply that. So the inside thing has to be made in cos. So let us put x as cos theta. So 2 cos theta minus thrice of under root 1 minus cos square theta. So 1 minus cos square theta, 1 minus cos square theta is sin square theta. So it will be under root sin square theta, sin theta will come. So it will be 2 cos theta minus 3 sin theta, And in denominator, let us take this like this, 2 by under root 13, this is under root 13. Now we can write this as some cos phi, because I know what is going to be sin phi. I'll just show you. Cos phi, cos beta, theta, whatever you want to write. Cos phi we have taken as 2 by under root 13. What is going to be sin phi? Under root 1 minus cos square theta. So sin phi is under root 1 minus cos square phi. Cos phi we have taken as 2 by under root 13, square it. So you get 4 by 13. 1 minus 4 by 13. So it will be 13 minus 4 by 13, which eventually comes to under root 9 by under root 13, 3 by 13, 3 by under root 13. So this has come, if we put cos phi as 2 by root 13, sin phi is going to be 3 by under root 13. Alright. So this is cos theta, 2 by under root 13 we have taken as cos phi, minus sin theta, and 3 by under root 13 is sin phi. So cos A cos B minus sin A sin B. What is cos A cos B minus sin A sin B? It is going to be cos A plus B. Well, we know that. So it is going to be cos theta plus phi. And cos inverse was already there outside. In the beginning, it was cos inverse outside. Now you can cancel these two out. Theta plus phi it will be. So what is theta and what is phi? Theta from here, it is going to be cos inverse x. And phi, because cos phi was 2 by under root 13, so phi will be cos inverse of twice 2 by under root 13. When you take d by dx, this is a constant because it has no x, it is going to be 0. Cos inverse x is simply negative 1 by under root 1 minus x square. Alright, that's your final answer. This is here. You have to write like this, okay? I've been reiterating this always. Differentiate sin inverse 2 to the power x plus 1 dot 3 to the power x by 1 plus 36 to the power x. So 2 to the power x plus 1 can be written as 2 to the power x into 2 to the power 1. 3 to the power x is there. 1 plus 36 is 6 square. 6 into 6, that is 6 square. You have a x power, so you can write it as 6 to the power 2x. So 6 to the power 2x. Okay. Now this 3 and 2 you can multiply. 3 to the 6. A to the power x into b to the power x is a into b to the power x. So 6 to the power x. Then you have a 2 here. And 1 plus 6 square, 6 to the power 2x. So 6 to the power x. Let us put something so that we get a sign here. Ultimately we want a sign. So you can cancel these two out. Alright. 6 to the power x, I am putting it as tan theta. What do you get? Twice of tan theta divided by 1 plus 6 to the power x is tan theta. So it will be tan square theta. 2 tan theta by 1 plus tan square theta is going to be sin 2 theta. Sin inverse is already outside. So sin inverse, and then you have 2 theta here. So sin 2 theta, sin inverse, you can cancel it out. There is no periphery or boundary being given. So 2 theta it is. Theta is what? From here, it will be tan inverse 6 to the power x. So 2 tan inverse 6 to the power x. Now let us differentiate it. It is going to be twice. Tan inverse is 1 by 1 plus whatever content is there, square of it. So 1 by 1, 6 to the power x, so it will be 6 to the power 2x. Now differentiation of 6 to the power x is going to be a to the power x is a to the power x log a. Base is e. So 6 to the power x log 6 base is e. Now let us combine everything. Well, this is the final answer. Just to write it in a proper way. 2 6 to the power x log 6 divided by 1 plus 6 square can be written as, again, because we have started with that, 1 plus 36 to the power x. This is your dy by dx. This is your final answer. This is how you have to write, okay? Everything has to be put in words. Now, why is sin inverse 6x under root 1 minus 9x square? There is a boundary being given, and I would advise you and encourage you to use it whenever it is required. So we need something here so that we get a sign. This I leave up to you. there is another way. I'll use a crude way to solve it. If you put something and come up with something sine and sine inverse will get cancelled. And for that you have to check for negative 1 by 3 root 2 and 1 by 3 root 2 that you are not out of the bounds. But I am using a crude way. I will just take it as sine inverse theta and I will differentiate it. So sine inverse x differentiation is 1 by under root 1 minus x square. Alright. So this whole, assume it to be x or theta. So 1 by under root 1 minus square of total term 6x root 1 minus 9x square whole square, means square of this. So 6x whole square is 36x square. Root this will be a goner. So 1 minus 9x square it will be. This is the first part. And since we have to follow the chain rule also, we have to differentiate 6x into under root 1 minus 9x square also. This is the second part. So let us do it first. Means this differentiation by the product rule. We are going to complete that first and then we'll combine it with the solution we got for actually differentiation of sine inverse x or sine inverse that content. So you have the first 6x I am taking. 6x, then differentiation of under root 1 minus 9x square. Then we have a plus sign. Then we have under root 1 minus x square here, under root 1 minus 9x square, and d by dx of 6x. So 6x, differentiation of this is 1 by twice of under root 1 minus 9x square. Then differentiation of 1 minus 9x square will be 1 will be 0, negative will be there, 9, x square is 2x. So 9 2s are 18, minus 18x. Since we have a cx, 6x and 2 in the denominator, so when you divide it by 2, multiply by, that is minus 1980, minus 18x was there. And I see, and you also see that 6x by 2 is also there. So let us multiply 6x by 2 here. And this 2 3s are 6, 2 9s are 18, and 6 9s are 54. So it will be negative 54 and xx, so negative 54 x square it will be. So negative 54 x square. Finally, I am writing the final result, that is negative 54 x square. And there is the second part also we have to do, which is the differentiation of 6x. So let me just complete this. And now this is simply 6x differentiation is 6. And under root 1 minus 9x square will remain like that. Okay. Now let us take the LCM just to make it complete. So minus 54 x square plus under root goes single, that is without under root 1 minus 9x square. 6 is already there, divided by under root 1 minus 9x square. That is there. This is the first part. The second part is also, this is the second part. First part we have already done. So there is a choice. This is a choice. You multiply it inside. It will be 1 minus 36x square. You can multiply and 36 into 9 is 324. So you can multiply it and just take care of the negative and positive sign. I'm not deliberating on that. You know very well what negative and positive sign will come. The main idea is that you have to multiply it here and just write it with the second part, that is the green part which I'm showing, and that will be your final answer. Okay. I hope you got the idea. I tried to do it in a way mostly people will do, because understanding and at that time contemplating what to be put in 6x under root 1 minus 9x square so that we get a proper solution, right? I can tell you that it will be 2 sine theta cos theta, that will be going to be sine 2 theta. That sine and sine inverse will cancel. I'm just giving you a hint. If those who really want to attempt it, bringing sine theta in place of 6x under root 1 minus 9x x square, this 9x square and 6x can be converted. But what we are doing here is simply multiplication, some simple algebra, nothing else. So I'm not even telling what I'm doing right now. I'm just doing it, and you just go along with it. But just simple multiplication. Once the differentiation is done, it's all about multiplication. So you can come up to a point and leave the answer. That is what will be the final answer. But I would suggest you to do certain substitution so that you come up with some sign so that you can cancel this sign in sign inverse. Because we are solving the RD SHARMA, so I'm going with the solution and the answer being provided by them. So we need to get this answer. That's how we got this answer. But the final will be that we need a sign here so that we can cancel sign in sign inverse, and that is the better way of solving this. So this is all about this exercise 11.3. Thank you so much and take care of yourself.